Okay, so let's begin by working on the landscape as what you would be doing in mostly any kind of a project, right? Just building up the current condition of the site. So usually what you get is a DWG file from the municipality with some contour lines, and sometimes they are kind of moved up to the correct altitude, sometimes they're not. So I have like a small example DWG file right here that is going to be available to you in the download section of this course, and you can simply drag and drop it into your Rhino file. It's going, once you drag and drop in, it's basically the same thing as typing in insert, or sorry, not insert, import. It's basically the same thing. It's going to ask you, would you like to open file, insert file, import file, or attach file? In your case, you want to import the file because that basically just makes it so that all of the geometry that you had in the DWG file that comes from AutoCAD gets directly converted into geometry that is within Rhino. And usually that works like a charm, unless there are some fancy fonts that were used in the original file. So import file, hit OK, asks you a bunch of questions. Basically, would you like to import the trash as well? Sometimes you do, sometimes you don't. I would suggest at the beginning to definitely keep the default settings. Don't mess with the settings. After you're kind of used to Rhino and used to the procedure of importing, exporting, at that point you can start kind of investigating what ignore thickness does and so on. Right now we don't have enough time because I kind of want to go through the whole design process, so I'm not going to be explaining this in too much depth. Default values work almost all the time. Hit OK, gets imported. Notice how the layers are created here as well, right? And if I zoom in, are they locked? Yes, they are locked. So let me unlock the layer so that I can select the curves, select them, Z, S, enter, zoom selected to my shape right here, and I have my kind of initial DWG file. Notice how simplified it is, but it should kind of give you an idea of the process, right? Of how you work with this. So the first thing right here is to notice that it's flat, right? So the ISO curves, the contour lines of the landscape are not in the correct heights. There are certain tools in Grasshopper, like more advanced tools, that automatically lift the ISO curves, but those require you to have kind of machine learning and artificial intelligence experience, which not many people have. So let's do it manually, like big boys and girls that we are. So first of all, 173, that's our lowest altitude, and we just lift up 173.5 by, well, 500 millimeters. Now when I think about it, we need to make sure that this is correct in scale, right? So I'll just measure the distance, let's say of this tree right here, and I see that the tree size is, or tree radius is 2.4 millimeters, which definitely is not correct, right? It should be either, my assumption right now is that it needs to be meters. Let's see here, 3.35 millimeters. Yes, this is most likely wrong scale of a drawing that you got, and that sometimes happens if a DWG file has been saved in meters and you open it up in a file, in a Rhino file that works with millimeters, it's going to import in the incorrect scale. So always double check with typing in dist or distance, and just click between 2 points to double check the size of things. So now that we know that this needs to be 1000 times bigger, I can just type in scale, click on the bottom left corner of my drawing, basically the 000, and type in 1000. ZS to zoom into it, and now I know for a fact that this is the correct scale. So where were we? We were lifting up our contour lines to the correct height. Well, again, the lowest point, so here, or lowest curve, then this one is going to be 500 millimeters higher. 174 is going to be 1000, or rather, sorry, let's go back. It's much better if you select all of the curves, and let's lock the tree and the markups layers and the border, side border layer, so that we don't accidentally select them. I'm just in the layers menu locking those. And let's select all of the contour lines right now and basically move them up by 500, and then unselect 173.5, move them up by 500 again, unselect 174, move them up by 500 again, and so on, right? So now notice that there are two ISO curves that need to be unselected for 174.5, then two ISO curves for 175, and from here on out it should be pretty simple. Yep. So we have our landscape done, or not done. We have our ISO curves lifted up. And by the way, this is only going to be the first type of geometry, or the first phase of geometry creation. The second phase is going to be pretty funky, so be prepared to go crazy really fast. So we have ourselves these NURBS curves right here that are kind of engulfing not engulfing, but marking out where the different heights of the landscape were. So to actually build it, I will be using a tool that I said that you almost should never use. Well, except now, it's called Patch. Patch interpolates a surface through a set of geometry, right? So notice how I have all of these contour lines selected, and I type in Patch, and here I have my surface pans 10 by 10, which is pretty low resolution patch. And also it only creates a patch here because that's the only enclosed curve in the whole set of curves. So to force it to go through every single curve, you need to untick the automatic trim option so that it doesn't try to be smart. Untick that, hit preview, and now you can see that my landscape is being created. Right, and it fits on the curves quite nicely. Let's increase the resolution to 30 by 30. Hit preview. Now it fits even better. I would argue that at a certain point, the whole procedure has diminishing returns. So 30 by 30 should be good enough. At least in this case, I'm basically looking at 2 meter step size, 1 meter step size. We could do a little bit more, 40 by 40. Yeah, that seems like it should do the trick. Hit OK. You have your surface. Let's create a new layer and call it landscape NURBS. Landscape NURBS, and just change the object, change the landscape into that layer, right? So now we've successfully made landscape surface, which can be used for the building placement, which actually now is the time when we create or where we specify where the building is going to be placed, and we decide on its form. So you as an architect, you probably have your own methodology on how you form find and how you create, you know, your architecture. So this is by no means a prescriptive approach to creating architectural geometry. This is just for me to showcase the process, and I will try to keep things as simple as possible by making something you know, quite simple and quite fast. So let's start with a box. I will just make a box right here, and I'll type in how big? Let's say 4 meters or 5 meters, 5,000 millimeters by 15 meters, 15,000 millimeters. Something like that. Enter. I think I forgot to add the height. Yes, I did. No worries. I will just move the box up, and I will scale 1D, and I will just scale along the height to whatever size I want, to whatever, you know, ceiling height I want. So I'll just do 4 meter high box. Okay, that is my box number 1. Let's make a copy of this up. Let's make another one real quick, and I'll just have this rotated just like that, and I'll move it. But one thing to kind of show to you in terms of the process, if I want to this box to move right on top of this one, just using the gumball kind of sucks. Using move, I would need to snap to this point, which doesn't move the box just vertically down. So how do I move it just vertically down until it touches the top surface? Well, that is where you select the box, type in M, enter, M short for move, and then you type in V, enter, or click here, vertical. So now the movement, as I start to move it from this point right here, the movement is locked on the Z axis, right? Meaning that if I snap to this corner point right here, the boxes will lay flat on each other, and the top box will not be shifted in neither in X or Y direction. Hope that makes sense. Okay, now I'm going to make it a little bit wider in the top, and also I'll make the overlap a little bit bigger. So the first thing, wider. I could just start doing scale 1D like that from here to here and specify 7,000, right? And just click, and now it's wider. Or I can right click on the gumball menu here, align to object, choose align to object, Control Shift, click on the face, and then just drag out the face as much as I want. 2 meters. Right? So it gets dragged out. Then this face, drag out 2 meters more. Something like that. The whole box gets moved down by 600 millimeters. Something like that. And perhaps, no, that's fine. 600 is okay. So that's plenty of space to have a vertical connection, I feel like. So we're going to stick to it. Now when I look at this, this could be longer. So let's add 5 meters to this. Yep, looks about right. And maybe this is a bit shorter, or maybe not a bit shorter, but rather this edge actually moves to here. I don't like it. I'll undo it. We'll keep it this way instead. All right. So we have our 2 boxes. I will make them into one by using Boolean union operation. Select both of them, type in Boolean union, and now they are merged into one shape. Now to actually move the boxes onto the wherever I want them to be in the landscape, I will just simply position them like so. Easy as that. Right. So now this is where it starts getting a little bit tricky. We have our kind of footprint ready to go, and the footprint is basically this surface right here. And let me mark it out with a curve. I could just draw a curve, you know, just simply do the rectangle, or I could actually, let's hide the landscape for a bit. So I select the landscape, I type in hide. I could just select the edges, Control Shift by the way, to be able to select the edges, and type in dupe edge to get the polyline out here. Join it up, join everything up, and now I have my outline curve, and now I can show the landscape again, but this time I hide the building. Or actually, let's be smart about it. Let's create a new layer, call it building volume, change object layer. So this object I select it, and to push it into this building volume, I right click, change object layer on the layer name itself. Now I can hide it through the layer settings. I have my little surface here, right here. I notice how I lifted it up. I actually should probably push it down on the ground. So I'll use project to C-plane, delete and put objects, yes. So now it's flat on the ground. And the reason why I'm doing this is because I will not be using a NURBS based landscape. I will rather be using a sub-D based landscape. And to be able to use a sub-D based landscape, I need to, I need to build up series of patches of sub-D geometry that follow said landscape, right? So this outline is basically where the patches should align with my building footprint, right? So that's why I got this building footprint right here. Let me hide the surface again, or rather, let's just hide it in the preview, like so. Go to the top of the view, or top view. Hide everything except the footprint, and let's start building in patches a landscape that we a drawing, I guess, of the landscape that we wish we had. I can actually even show it to you this way. Maybe this is going to be more informative as to what I'm aiming for. Let's say this building right here, right? I want it to have like a soft terrace around this area, and then kind of taper down here into something else. So there's going to be a shift. So the amount of divisions that I'm going to have is going to be pretty low here, while it increases in this area. That all of that will be done not automatically, but needs to be described by me with line work, right? And let's just do it in perspective view. So I'll just create a new layer, call it helper lines, make it blue, change this curve to that layer, and make it active, either double clicking next to the name, or just clicking the tick mark area here. So make sure that the tick mark is there, and now as you're drawing in that particular line. Make sure that ortho is turned on so that you're at 90-degree snapping, and let's start drawing. So let's say the terrace is going to be 500 or 5000 millimeters by car plus pedestrian path 3,500, 3,500, and it ends here. It's a big building. Doesn't need to be perfect. All of these are just helper lines. We will be creating a sub-D form from this. So that's one. Then we will have a bunch of kind of patches running around here. So this is going to be 5,000 again. Like that. This is going to be our area for where it kind of tapers down, right? Like that. So that means here we will have a patch doing something like this. This is one of the areas where I actually can get used to smart tracking, something like that. And this should be almost, yeah, this should be good to go. The other side can be just a mirrored version of this side. So I'm using mirror command to mirror one side of the curves to the other side by just specifying midpoint here, midpoint here as my mirroring area plane. All right, so this is like a good starting point for me to start building the sub-D geometry from. So I'm just going to go to sub-D tools. I'm just going to create a new layer, call it sub-D, my sub-D layer. Make it active. Select create a single sub-D face as the tool. And just draw one patch, doesn't matter where, as long as it's, you know, within the boundaries of the one of the regions that you've specified, right? So basically I'm just creating one of the islands. Then after I've done this, I can use a command that's called append face. Append face basically adds more faces to a sub-D geometry. So I can select this little guy right here, hit enter. Basically I'm saying that I'm going to be appending faces onto it. And then I just pick points and I just keep creating sub-Ds. So these 4 points, hit enter, gets created. 1, 2, 3, 4. These 4 get created. 1, 2, 3, 4. These 4. 1, 2. You know the drill at this point. You know the drill. So we are creating this grid of forms, right? And this grid is not going to be super clean, I guess. Is clean the correct word? No. It's not going to be finite. Meaning that, or finalized, meaning that we will be working on this even more. But now if I hide the helper lines, you can see the grid in place. Notice how there are bold lines and there are thin lines. If I hit the tab button, you can see that the smoothing is messing up all over the place. That usually happens when you don't have things joined up properly. So first of all, make sure that select all of your sub-D geometries, type in join, enter. So it joins up and it seems like it fixed part of the sub-D, but there is still one part that's messed up. And if I were to show you why it's messed up, usually that has something to do with the vertices. Yeah, there we go. I misclicked when I was creating the patches, right? So these are not in the same plane. You can very easily Control-Shift click on the 2 vertices here and type in stitch. Stitch will connect the 2 vertices into one, merge the 2 vertices into one. You can either say that it's average or with your mouse specify on which point you want to stitch. In this case, it's going to be that point right there. I assume same thing is gonna happen. Is it here? It's probably here. So Control Shift, I'm just selecting one of the points, moving it away to just check. Yeah, it's probably, if we just stitch these two onto here, now it's fine. Seems like it's doing everything correctly except here. Why is it bending there? I've never seen it behave this way before. So this is new to me. Give me a second. Yeah, it feels like this area right here, you know, since everything is kind of like a nice grid and this is just whoop, loops out, there's something funky. And 99% of the time, if there's something funky going on with the sub-D geometry, it's most likely the points are duplicated. They're double, maybe in the same place, but there's 2 points. So Control Shift and just dragging around this area tells me that there's only one sub-D vertex, which is very weird. It should be 2. That would be at least my assumption as to why this is messing up. Since it's only 1 point there, I am going to just extrude. So I'm selecting Control Shift, these 3 edges, and then not holding Control Shift at this point. I just click on the small little dot here for extrusion, and I just extrude them out to create one more row of polygons. And now notice that, yeah, it's all messed up here. So inside of your shape, you never want to see thick lines, right? It all needs to be smooth. So there is something wrong there. Let me switch to wireframe view. Control Shift, drag around here, and it still says, it insists on saying that it's a single sub-D vertex. So at this point, I believe that the geometry is actually clean. What is not working here, it's actually the creases. So sub-D can have a crease. I haven't mentioned this before, I will mention it now. If I were to create a box, and you can see it smooths out quite nicely, but I can also select, for instance, these 2 edges and type in crease. And then it becomes this kind of a bold line. And if I hit tab, you can see that it adds this kind of a 90-degree angle, or not 90, but a sharp angle to your sub-D geometry. I believe that this is a very confusing tool or part of the Rhino sub-D modeling, and I wish it wasn't part of Rhino, but it is, and it's something that we need to deal with. So what we can do is we can just select everything, Control Shift, and just drag around the whole sub-D shape and type in remove crease. Remove crease. And you can see that after I've done that, it removed all of the creases from my geometry, and now it's good again. So that's a thing that happens. Yep. Okay, let's continue. So here, at this point, I'm just going to kind of start building out my my landscape grid by slowly kind of just selecting the rectangles, or not rectangles, sorry, the outer contours, the outer edges, and just extruding them out by as much as I want, right? Visually, I just visually make a decision by how much I will extrude it. If I need to, at later stages, I can extrude more. For now, this seems like it's fine, like it's good enough. Now it's time for some advanced stuff. So, or not really, somewhat advanced. I have a landscape like this, and I have a flat subd landscape like this. Let me move it up so that you can see better. How do I make this landscape curve according to the landscape that we already have? Well, I can just select all of the vertices of this landscape, or the whole thing actually, and I can just type in project, not to C-plane, just project. Wait, apologies. I forgot one thing. Oh, I'm getting tired. I will stop soon. Again, without having anything selected, hit escape. Without having anything selected, we type in project, enter, select curves and points to project. We don't have any curves or points, right? We technically can click on the points of this subd geometry, but that would take too long. If I just drag around the subd form like that, then it catches all of the points. So that's one way of how you can do it. Another way would be to hit F10 and then type in cell PT, but this one works, so we use it. So we have these points that are going to be projected. I'm happy with it, and I'll just hit enter. Then it asks me select surfaces to project onto. Okay, this is my surface. And what happens when I press enter? My subd shape just gets projected on top of this surface. And as I hit tab, it gets moved out as well, right? So now, instead of this NURBS poly surface that is hard to mold and shape, I have this subd poly surface that is, subd shape that is much easier to mold. If I were to show you the building volume, because at this point we should look at the building volume, looks like that. Not that great, but now I can actually start taking the vertices and moving them down. Just so that I don't move the building anymore, accidentally move the building, I will select it and type in lock. Lock to lock it. To unlock it, you just type in unlock. Right, it gets unlocked. And now what do? Well, we take the corner points and we start moving them around. Like that. This one. So we need to make sure that everything kinda fits. This one, move to maybe here. This one. Whatever to here, that seems fine. And now we end up with a form such as this. All right, I said that here I want a terrace that should be flat. Well, by no means should this be considered flat. So I will take this point and I will M, enter, V, enter, move, enter, vertical, enter, from its original position to the same height as my building bottom corner point, like that. I'll repeat it for this point as well. M enter, V enter to here. And now this surface right here, or this part of the subd is flat. Then when I look at this is not good enough in terms of the, the slope. This is a very annoying slope. So I can very easily introduce more resolution here by just Ctrl Shift, double clicking one of the edges to select an edge loop. When you double click, Ctrl Shift double click, it selects the whole edge loop, and typing in insert edge, and basically sliding out from it, just let's say somewhere here, something like this, more edges, yay. And then I just select this, M, enter, V, enter to the edge right there, select this, M, enter, V, enter, to here. There we go. We have a landscape, right? Now to get more of it, I can just select, well, I should probably just double click, right? Oops, not really. If you, when I double click, it gives me the whole perimeter, right? So if you just want to get this edge without selecting every single edge along this area, then what you can do is Control Shift, select the first edge, select the last edge, and select an edge, double click on an edge in between, and it's just going to kind of fill in the remaining edges. And we extrude it more. The gumball is crooked, that means my gumball alignment is set to object. I don't want that, I want it to be aligned to C-plane, and I'll just drag it out even more. At this point, these points right here, I believe we should, let's see, where's my landscape? There it is. The points should be projected back onto this landscape, right? So we project, select only these points this time, enter, onto the landscape, and now they are all following the landscape nicely. Tab. This is good now. All right. So, for instance, here, you might want to have a sharper change in the height, or not the height, but the sharper change in the continuity of the surface. So what you can do is you can just double click, get these edges here, insert edge, and just insert more edges away from the building so that you can see the change is more drastic, it's faster. I would suggest to never ever crease anything, because that is just a recipe for disaster. It's so much better to just insert edges to get this kind of a smoother fall down. If you want to, you can do 2 inserts on both sides, right? So then it's definitely a much more aggressive fall. In certain places, you don't need this to be double anymore, or even triple. So for instance here, let's say, while let's say here and here, it's nice that it's a little bit sharper, and it's hard to show. Emap. With Emap, it's gonna be easier. There we go. See the sharpness here that is created by the double edge, and the sharpness here that is created by the triple edge. But let's say in this area you don't want it anymore. Well, that is where you actually can take 2 vertices, let's say these 2, and stitch them together back into 1. And take these 2 and stitch them together into 1. So this is what happens, and it kind of smooths out in this area, right? And we're going to do exactly the same thing here. If I remember correctly, it should work with curves as well. Stitch. Yeah, you can select 2 line segments and stitch them like so. This one can just be removed, right? Because this is like a quad. Ew. Looks bad. Let's not. Still looks bad. Give me a second. It's not great. This is a little bit more complicated. Okay, so it does really want to do this kind of a not fillet, how do I call it? Like reverse fillet thing. By the way, I achieved this by just selecting an edge and just hitting delete, right? Because this is a quad. Sure, we can keep it. Let's just do an emap to just double check. So from hard surface here, it becomes smooth surface in the bottom. Yeah, that works. That actually works. So slowly we're kind of shaping the landscape to, you know, whatever we want it to be. Let's say this hill, or rather, let's extrude this out even further. Let's say this hill is too high, then you can just simply move it down, right? Because the earthworks that are going to be done, the earthworks that are going to be done for this landscape are going to be done either way, and they're going to be soft earthworks, right? They're not going to be hard earthworks or hard surface earthworks. So you kind of are able to just use this as a means of shaping the design. All right, so we have this done. If you want to have even more control over the shape, all you need to do is just kind of keep adding edges, keep modeling with it, and eventually you'll end up with a pretty detailed landscape that later you will be able to extract the surfaces from. For now, I think we will stop here with the landscape and we will move on to actually designing the insides of the building in a very simple way. You know, this is a beginner course, so it's not going to be anything super fancy. All right then, so let's continue with our little project. So I took the liberty to model out the landscape a little bit further. It's nothing fancy. I just moved some points around, moved some curves around. For instance, that hill, you know, I just enter, V, enter, and just place it down here. This hill, same thing, V, enter, down here. So I basically went around for 5 minutes, the whole landscape, and tried to get the immediate surroundings of the building a little bit more locked in. No additional tools that I haven't talked about were used. Everything that I used, I already kind of explained it. I also sharpened up this slope. The slope right here, the start and the end of the slope. If I hit tab, you can see it being sharper now. I think the down drop here will be a much, you know, architecturally speaking, it's much nicer to have a steeper drop rather than a very, very shallow drop, especially considering the cantilever that we're dealing with here. But again, that is design. We're not designing, I'm just showing the tools. I constantly need to stop myself from doing that. Anyway, so from this point on, by the way, the file that we have here is going to be called stage 2. So I will just save this file, and you can of course get it from the download section, and I will create a third file called stage 3, where it's basically going to be stage 3 is going to be the file that you will get after the current session has ended. So I will mention this again once we're done with that part. So what do we do now? Well, now is the time to actually figure out what we're going to have inside of the building, right? Or inside of your structure. So how do we do that? Well, one way would be to just draw out the rectangles, get them on the side here of the 3D model, and start detailing or start drawing inside of those rectangles, figuring out, you know, where the entrance is, where the partitioning walls are, and so on. But in my opinion, it's much better if you have, let's say, just a section, like a plan section and the projection of it. Because while here we're dealing with rectangular, like boxy objects, what if your geometry is a little bit more complicated than this? Then you would be in trouble. So I will show you one little trick, or not trick, a tool. The tool is called clipping plane. Clipping plane, and as you basically just draw the clipping plane as a rectangle. So we can, and the size of it doesn't matter, by the way. So I just draw it like a rectangle, and you can see it basically trims away all of my geometry. As you select the clipping plane and you start lifting it up, you can see that it's, it's literally like a section, a rectangle that dictates where a section is. So it dictates the altitude of the section. A very useful tool. So for me to get the section plane of, let's say, the first plan, like so, all I need to do is just position it in the correct height, and then go to the top view, change this to shaded view, and then I notice, while in the top view, I notice that, well, it's not cutting my geometry here, right? While in perspective view, the clipping plane is indeed cutting the geometry. In the top view, it's not. So what's happening here? The reason why it's not doing anything in the top view is because of the properties of the clipping plane. So if I select the clipping plane itself, and I go to the properties on the right hand side, the properties tab, you can see that my clipping plane properties, by the way, if you don't see it, it's this icon right here where I have my mouse. My clipping plane properties says that it only works in the perspective view. It doesn't clip the top, front, or right views. So to change that, all I need to do is just tick mark the top view, and now you can see that there's a section going on here. Perfect. Now what I'm going to do is I'll just select my my building. I can do that in the perspective view as well, or I will just do it in the top view, like so. And I'll type in make 2D, make two-dimensional, make 2D, enter. This menu will pop up, which will ask me for a bunch of different things. The main one is what's the view from which I want to generate a two-dimensional drawing. In this case, it's just going to be a rectangle. It's not going to be anything fancy, but we will make it a little bit nicer later down the line once we will have more geometry to deal with. But for now, the view is the top view. Projection, it needs to be according to the view, right? So straight down in terms of the view. Then what kind of properties should the lines that are generated inherit? So I prefer to have the property set to be by output layers, so that my geometry, or not geometry, the line work that is generated is controlled through the layers that are going to be generated for the make 2D drawing. You'll see what I mean in just a second once we accept this. And at this point, it's basically what kind of all of these tick marks are what kind of a settings do I want for my make 2D to work. So tangent edges, do I want those? Not really. As an architect, you usually don't. Hidden lines, would you like to see some any of the hidden lines? Not really, I don't. Scene silhouette, that basically gives you the outline of any object within the scene. That's very good for diagrammatic objects, but not that great for like proper two-dimensional drawing. So I'm gonna untick this. Clipping plane intersections, that's a very important one. This is basically a layer that is going to be generated for all of the lines that are that mark the position of the section. So in the case of this rectangle, there are going to be these lines, the rectangle itself, right? So all of the thick lines in an architectural drawing, the stuff that you cut through, that's clipping plane intersections. Viewport rectangle, never have that open. Group output, sometimes you want to group output, especially if you have like a very, very heavy 3D model, then you don't want all of those lines to be separated out. In this case, again, just a rectangle, we don't care. And register with previous, we don't need this. Layer name, I'll just call it first floor, or let's just call it make 2D. Make 2D. Just simple make 2D. Hit OK. And it generates a rectangle for us. That's a long way of making a rectangle, I know, but this is accurate to whatever geometry you have here, right? That you had selected. If I go to my layers tab, I can see that make 2D main layer is created, which has a sublayer called visible. Basically all of the lines that were visible during the export, and that visible layer has clipping plane intersections. If I change this particular clipping plane intersections layer to red, you can see that this curve changes to red, meaning that this actually, or these 4 curves live inside of clipping plane intersections layer. Now, if I go back in here and I lift up this clipping plane to something like so perhaps. Yeah, that should do the trick. So that we're cutting through this rectangle here, the second floor, and I will select these 2 objects again. Oops, not the landscape. We don't care about the landscape at this point. I type in make 2D again. Select all of the settings are exactly the same. Hit OK. It generates a second geometry for me, right? So this generates my second floor plan. So now I have both of the floor plans and I can start working on them. I can start detailing them. I assume that you know how architectural drawings work and how you can work on them. And how you should work on them. It's not going to be anything special. Also, I should probably have these in a separate layer. That's gonna be layer. So I think what we can do, I will start by kind of explaining the initial thought process, you know, like offsetting and so on, but then I will speed up the process of me just creating the basic plans for these 2 volumes so that we can move on with the actual design or actual like the progress of designing this building. So I will start with the first floor and I'll just offset and I'll specify that, okay, offset. I'll specify that the distance of the offset, you know, let's say 400 millimeters. 400 mil inwards. Notice how the layers don't match, and that is because sub D layer is currently my active layer. I want to make clipping plane intersections my active layer so that all of the geometry that is going to be created in that layer. So I have these 2 curves. For now, I'll keep the plan 2 untouched. All right, so this is my outer perimeter, and I have an entrance right here, I believe. Let me double check so that I'm not lying to you. Sorry, no, the entrance was actually right here, wherever I wanted, but it's basically here. So I think a smart way would be to get like just a line in here, move the line up by, oops, not 50. Let's do 1.2 meters, 1200 millimeters. Give it an offset of 200. You can do 220 millimeters. It's gonna be like a semi-retaining wall or a fully retaining wall. F10 to get the control points of the 2 curves, and just move the curves, M, enter, back to the perspective snap. The snaps all can be controlled through here, and notice that I'm using end snap, near point snap, point, midpoint snap, intersection, and perspective. Basically, you don't want the center snap because that gets annoying really fast, and tangent and quad snaps are only useful when you're dealing with circles, so usually I have those turned off. Everything else you should probably have turned on. either way, we have ourselves a small little wall here, right? So let's say you enter right here, then you immediately are able to take a left turn, and let's say, let's just draw a line there, and you can specify, if it's 1.2, we can give it like 1.5, 1500 millimeters, something like that. I'll just make it pretty wide, and offset 125 millimeters, and that is going to be like your bathtub area, not bathtub, sorry, toilet, the toilet area. And I will clean it up a little bit, like that. Then this area right here is going to be where you're heating, what else? Yeah, that should fit. Where you're heating, where your ventilation, boilers, and so on are, right? So in regards to that, this is a little bit too small for a building like this, for a house like this. So I'm going to give it a little bit more breathing room. And by I'm just going to design it in a way that, let's say, there can be a hiccup. Actually, let's create a rectangle here, and let's just measure an area 30 square meters. That's a lot. Actually, that should be more than enough for also for a little bit of storage, so we're keeping it this way. Then we need a vertical connection, so we need to figure out where the vertical connection is, and I'll just kind of separate out the different rooms in the building. So this is the moment where I speed up the process, because it's all going to be just offsetting and trimming. And after I'm done, we will continue. Okay, so we're back. So this is how much I've done, and I don't know. I could check, but it was pretty fast. Just the vertical connection has been solved, nothing more. And honestly, I think just by looking at it, I think this is going to be enough for me to kind of convey the whole thought process behind modeling in Rhino, because everything is just a repetition of whatever we'll be doing here. So now, also, as I was modeling this, the staircase as it were, since we have a 4-meter slope, not slope, 4-meter height in the first floor, the staircase didn't fit properly, so I had to give a little bit more breathing room, especially on this, along this edge right here of the building. So as you probably saw in the footage, I have added 50 centimeters, 500 millimeters to the thickness of the building. So right now, as it is, it's 5 1.5 meters instead of 5 meters wide. The length of it is unchanged. So we have, once you enter, you get the, you know, the bathroom area and or toilet area, and then you get the ventilation, blah blah blah, like the, how do you apply utilities, utility area here, and then you're able to go up the stairs, up on this floor, and kind of carry on with your day here. Right, so nothing is solved in these two. I just use them both to just generate this vertical connection between the two plants. Now we are going to replace this volume with the, you know, like proper walls, proper floor slabs, and so on. So building components, because this volume as it is just a solid piece of geometry, while from these we can actually build up our building. So what do we do? Well, first of all, I always like creating separate layers for separate types of geometry. So let me create a new layer, call it slabs. Create one more layer, call it walls. And I could make a separate layer, interior walls, exterior walls, but for now just walls. Then one more layer, call it stair. And I think that's going to be it for now, because we'll have slabs, walls, and a staircase. Afterwards we will add windows and doors, and then we'll call it a day with the design of these two boxes overlapping. Alright, so in terms of creating slabs, I'll just make it my active layer, and I'll make the slabs, let's say dark green. Let's say our layer of slabs is dark green, and I'll just make a box for the bottom slab right here, and I'll extrude it downwards by whatever the slab thickness should be. Since it is going to be a cantilever outwards, I believe the slab should be pretty thick. So let's go for 600 millimeters, minus 600, enter. That's our floor slab. Then we will have another one that's going to be our floor slab here in the second floor. But I believe we will do that a little bit later. So we're going to kind of grow the whole building from the base layer upwards. Right, so I'll just jump to wall creation, and I'll just start creating walls. Let's choose some other color for the walls. Let's go for cyan and just start drawing. So first of all, the slabs, I will lock that layer so that I can't select the floor slab. And now for the walls, you could clean everything up and just extrude, make a planar surface out of a cleaned up version of this and extrude it. I think I will go for a series of boxes, just because it's, I don't know, it's just a matter of preference, I guess. So I'll take my boxes here and I'll start extruding. So how high should the walls be? Well, I could measure here and subtract the height of the slab. So 4000 minus whatever the roof is going to be, or we can go other way around and we can just create our own. I think let's do 4000 minus 600, 3400, and then if we need to, we'll just scale everything down. So 3600 or 3400, sorry. Another one right here. Now, since I have that top to snap to, it's going to be a little bit faster. Third one, fourth one, then interior ones. This one right here. So, like straight walls is so easy to do. If you're doing like curved walls, then the approach that you would have would be, let's say, have something like this. Let's say you have a situation something like this, then you would need to force a closed region. So I'm just drawing a line segment here and a line segment here. Then I would select everything, join into one closed curve, make a planar surface, planar SRF out of this, delete the curves because now I have the surface to play with, and then just simply extrude, you know, with the ball here, extrude the surface by 3400. And I have a wall done out of the curves, right? So that is an approach, like an alternative approach to this. There are so many different ways of how you can do it. It's crazy, right? So you just choose whichever you prefer. Then for this separator wall, since it's not angled along any of the axes, I need to actually use a 3-point box. So the way you do it is you start drawing a box, just, you know, without clicking anywhere. You choose 3-point mode. You choose where you start, what's the start of your edge, what's the end of your edge, then where the width is of the wall. So you can, you know, choose the side. So like that. And then the height. So start, end, width, height. And just creates this nice little box that follows the any direction you want. Again, repetition. We can do 1, 2, 3, and 4, right? Notice that this box is actually not intersecting properly with the wall here. I can force intersection by just Ctrl-Shift, selecting this face, and moving it along this edge. Two ways of how you can do that. Either type in M, enter, and then choose wherever you want on this edge, and snap. While you're snapping along this edge, is going to move along this edge, right? So then you can just type in, you know, 200 millimeters, and it's going to move along this edge by 200 millimeters. Another way would be to right-click the gumball toggle. Right-click it, align to object, Ctrl-Shift, select the face, and now the gumball is aligned to the face, so you can just click on the arrow and type in 200. And it's going to move along the normal of the face, like perpendicular to the face. Then you align to C-plane and you have overlapping walls here. You need this to be cleaned up. So what do? You do Boolean difference and you subtract from this wall, enter, with this wall. But you don't, after subtraction, you don't want this wall, the big boy, to be deleted. So for here, delete input, you'll choose no. And then select the big wall, hit enter, and now it gets subtracted. These two instances, right, this one and this one, these two instances can be a single piece of geometry. So I will just select both of them and type in Boolean union to merge them into one object. And notice that after merging, there is still a seam here. That seam initially doesn't do anything, honestly, unless I use Ctrl-Shift to select in the top face, and you can see that only this area gets selected, or only this area gets selected, not both of them. If you don't want to have a seam there, you can always force the merger between the two faces that are planar by selecting the whole object and typing in merge all coplanar faces. It's going to get rid of the seam right here. All right, I'll do the same thing with these two walls here. Boolean union. Merge all coplanar faces. There we go. And I'll do the same thing with these four walls here. Boolean union, merge all coplanar faces. There we go. We have ourselves like a set of walls, I guess. That should work just fine. Now on to creating a staircase, or actually no, a staircase will come later, a bit later, because now we still need to create the whole second floor for this. So the way we do a second floor is actually we need to understand that the ceiling here and the floor here are going to be the same plate, right? The same surface. So I'm going to create a polyline here. I'll just draw a polyline around the whole region. I think I messed up. Yes, I did. Control Z to undo. And this time actually click on the correct... Oh, I messed up there as well. What the hell? Is that a fillet? That was my bad. I'm sorry. Give me a second. Let me fix my mistakes. Yeah, that was just a 10 millimeter fillet that I did earlier on while drawing. Always when you fillet two curves, always check if the radius is 0, or else it's going to make a very small arc that you will have troubles with, you know, redrawing later on, just as I did right now. Anyway, I have myself the outline that I need to draw. So let's go 1, 2, 3, 4, 5. Intersection point, snap right there. 6, 7, 8, and 9. This is probably correct. I assume the snapping worked. And that is my floor plate, or floor plate of the second floor and the ceiling plate of the first floor. Right? Planar surface. Enter. Then by the way, I deleted the outer curve as well. So I didn't hit enter, I actually hit delete button. I lied. And we extrude the surface by 600 millimeters. It's, you know, a pretty thin roof. Well, it depends on where you're from. For Sweden or Lithuania, it's a pretty thin roof. Either way, I snap it to the correct position by just using move command, move from this point to this point, and now I have my floor plate here. Notice that the layer is incorrect, right? So I'm going to select my slab, and I'll actually right click, change object layer, and move it to the slab's layer, like that. Perfect. All right. Now, well, guess what time it is. It's time to actually make the outer walls, or not the outer walls of the second floor. And I already have this offset here done. It's literally just a rectangle and an offset of it. So I'll cheat a bit. I'll do planar surface to just create a surface in between the two curves. It's smart like that. It understands that if you have a large region, closed region, and you have a smaller one inside, then the smaller region is a hole in the larger region. Anyway, so we have that surface. I just extruded 3,400, I believe. Let me double check. Yes, 3,400. Move it into correct position, like that. Have my walls, and then I will be doing planar surface, or actually let's just do it here, because it's now going to be just easier to make a box with slabs turned layer being my active layer. Make a box, 3-point box, and just choose bottom left corner, bottom right corner, top left corner, and for the height 600 millimeters again. We have our little slab doohickey here. Easy. All right. So now it's time to actually take the slabs and the walls that we have created and move them into the correct position. So basically replace this with this. So to do this, let's decide on from which point kind of aligns. And I think this point, I'm just going to place a point here. You can see right here. I just placed a point there and a point here. So these 2 points actually match up, and I will be moving the walls and the floor slabs from this point on to this point. So let's do that. I will select all of the objects that I have in my slabs layer, right click, select objects, and all of the objects that I have in my walls layer, right click, select objects. So these are now selected in my viewport. I'll type in M, enter, short for move, and I'll just move them from this corner point, as I said, to this corner point. There we go. Click outside. Now we have some overlapping geometry that, we need to fish out the old version of this, delete, because now we have the new version. Like that. I believe that, let's select the whole building. I believe that we need to have at least a little bit of an altitude, a little bit of a step between the outside dirt and the inside. So I'm just going to take the whole building and move it up by 0.1 meters. 100 millimeters. There we go. So it's just slightly, a small step so that when it rains, stuff doesn't flow in. All right. So now we have floor slab and wall system, nothing too fancy, but hey, it's a start. It's a start. I believe that now it's the time to actually cut a hole in the second. I by the way disabled the walls layer from being shown because we are going to be cutting into this floor slab to make a hole for the staircase, right? And I have marked out where I will want the double ceiling height to be, where the hole is going to be, and let me actually draw it for you. From here to here to here. Or, oh yeah, sure. Here, here, and here. We have ourselves a hole. I think that would look quite nice. You enter, right? And then there's this whole area where you can sit down, put on your shoes. There's underneath the staircase, you would have like a place to hang your coat, a mirror perhaps some, a window. Perhaps it's even a walk-through hallway, so you can choose to either go out on this end or on this end of the house. There's many possibilities on how you can make this quite a useful, usable space. Don't be afraid of awkward angles is what I'm trying to say. Anyway, we have this. Let's create a planar surface out of it. And let's actually extrude it by quite a bit. Something like that. The size of it, the height of it doesn't really matter. Something like 3-4 meters. And I'm going to just move it from the same corner point to the same corner point that we had here. So I'm just transferring my negative space object thing onto my building. I'm going to lift it up so that it definitely intersects with the floor slab. And guess what I'll do? Boolean difference from here with here, or from here with this, then select it, delete it, and we have ourselves a hole. If I look at the walls, and let's select the outer wall here and hide the outer wall, you can see that there's like a floor opening here that is waiting for us to actually give it a staircase. Speaking of which, let's model out a staircase. It's going to be pretty straightforward. I'm just going to... We could do it in a very, very standard way where we just kind of make boxes and we Boolean union all of the boxes together, because this is a pretty typical staircase. So, okay, let me explain. There are two ways of how you can do it. One way is creating surfaces, 4-point surface. Oh, and I should make stair my active layer. Like that, one surface, 1, 2. I'm using 4-point surface, by the way, for this. You can also use planar surface if you want to, it doesn't really matter. I'll stop here. So we have 4 surfaces here, and I'll just move them. This is going to sound weird, but it doesn't really matter by how much you move the top of the stairs, as long as you're consistent in the height. So let's say I move them by by 100 millimeters, which makes no sense for any kind of a staircase, but it's going to make sense in a second. So 100, that means this one would be 200, this one would be 300, right? Now we have, let me hide the make 2D. Let's get rid of that. Now we have 4 surfaces on top of each other. Oh, by the way, the first one also needs to be moved by 100. If it hasn't already, no. So all of these also need to be moved by 100 because the first step already is at, 100 millimeters above the floor plate. So now what we can do is we can create this zigzag. So we need to loft between these 2 edges. Loft, edge, edge, enter. Loft, edge, edge, enter. Remember that enter repeats the last loft, and then I'll just borrow the surface and just copy it right in here. And we get ourselves, kind of beginning of a staircase. Then there is this zigzag, and this zigzag can be finished up by, let's do it this way, finished up by just simply taking a curve such as this, moving it down by, well, actually we should be pretty accurate about this. So I'll just do minus 200, probably, minus 200. Finishing it off like so, and so. And we end up having, this boundary, which we can fill in. So we have the sides, and then you fill in this little end that's going to be Boolean differenced out by the floor slab either way later down the line, and you eventually end up getting a staircase. I will not be doing this just to save time, because this is not going to be the method that we will be using particularly for the staircase that I'm going to be showing to you. But why did we choose 0.1 meters or 100 millimeters in step size? That makes no sense. Well, because the way you control the height is you actually control the height not at the start of the stair creation, but kind of in the middle. Once you have the zigzag done, then you can do a bounding box for the staircase, which basically just gives you, a box in which the geometry that you have selected fits. And then you can select the box with shift together with the staircase and scale 1D, scale in one direction, the box together with the staircase from its base point to its top point. So along its height, you can scale it to whatever height you want, right? So let's say you want to cover 4 meters in height with 4 steps. You can, if you want to. You just type in 4,000. And that is how your staircase would look like. So you don't anchor yourself to some sort of a, typical step size for a stair, 0.175 meters. 175 millimeters. No, you don't do that. You instead do quick math, calculate approximately how many steps you would need. 4 divided by 0.175. You draw as many steps as you need, and then after you scale them to fit with the floor slab, it's all going to work out, right? So that's the principle, at least, of, well, the principle that I'm using, at least. So now let's actually do it in the proper way, or in a way of how I'm used to doing it. If we create a box, 3-point box, along this step 1, 2, 3, And then the height, you guessed it, 100 millimeters. For some reason it created the box downwards, that's fine. We just move it up by 100 millimeters, right? So we have our first step. Then I'm just going to take it and I'm going to copy it. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, we have these. And I'll be doing it the same thing for this, don't you worry. But basically, after doing this, I will move the already existing steps up by 100. Control unselect 100 again. Control unselect 100, 100. This is, I know that this seems like it's inefficient in terms of how Revit deals with the staircase, and how efficient Revit is with stair creation. But trust me, once you have custom staircases to deal with, then this just mops the floor. This kind of approach just mops the floor with what Revit proposes. Right, so while this is much slower, it's much more flexible, and that's the trade-off that you have, because this doesn't need to be a rectangle, this doesn't need to be aligned. It can be any shape for any staircase you want. I'll just borrow these and I'll copy, holding down the Alt key. I'll copy them sideways. I'll move them, let's say from this corner point onto this corner point right here. And what I want to do is I want this staircase to align with this row of stairs. So I'll use rotate command. I'll rotate around the only point that actually matches up. And then I'll choose, let's say, this point right here needs to align with this point right here. Bam. Something like that. Then I just take the stairs, move them up, M, enter, V, enter, from this point onto this point here. And actually it's going to be one more step, because the landing that we will have here is going to act like an additional step. So we move everything up by 100 once more. Then I draw the landing. Like that. Planar surface. At this point, you know the drill. 200, not 200, 100 millimeters. Extrusion, move, vertical, base point, top point. There we go. We have our landing. Like, this is ugly, and you probably would want to do like a double step. For instance, if we just take all of this, 1 second, all of these steps except the first one, Control Shift, and I'm selecting all of the base moments, not moments, what am I saying? Like the base surfaces, I can just move them down by minus 200 millimeters to give it more precision. Is the word precision? It's not precision, is it? Beefiness. To give it more beefiness, right? To have them more monolithic, and then I can start sculpting them. So what do I mean by sculpting? Also, what do I mean by this? Why is there a gap here? I assume this stair right here is 100 millimeters, while the stair in the bottom, because we're dealing with weird angles, yeah, that's not 100 millimeters. That's fine. That's not a problem. we just select all of these, or actually we don't even need to do that. We just select the stairs themselves and we'll use scale 1D, scale one direction or one dimension along the length. So from that corner point to this corner point, we scale them until they snap to this reference point right here. So now the new length will be correct. Okay, enough with that. We don't need the lines anymore, kinda. We'll still need this. I should add it. So I'm just going to create a box, and now it was 100 millimeters plus 200. So let's do 300 millimeter box and height. Move it. First of all, I'll just move it here, and then I'll just jump to 100 millimeters more. So it's one additional step. We have ourselves this monolithic looking Minecraft staircase. Let's turn off all of the curves and let's just join it all into one big blob. Boolean union. Everything now is joined up. Let's clean up the edges by typing in merge all coplanar faces. You can see how much cleaner it got. Now let's get rid of the jaggedness in the bottom. So I think the easiest way is just to create a line from that corner to this corner right here, and perhaps extend the line or not. No, I assume we don't want to do that because that's going to just mess with the remaining area here. So we're keeping it. So we just create this line here. Then we create another one on the opposite side. I'm just double checking. It needs to go until here. So we will have this line here and this line here. We create a loft between them. Just a surface. It's hard to see the surface. Let's go to shaded view. Sorry, wireframe view. That didn't help. Ghosted view perhaps. Anyway, there's a surface here, right? I will just extrude it to make it into a really big boy. And now with it, we can select the staircase, Boolean difference out the back plate with the loft, basically, right? There's still this lip to deal with, but I feel like the lip can either stay, or we can just take all of this and kind of move it even further down, you know, until the lip becomes 0. I think the lip should stay though, so we have it stay. Then we need to deal with whatever the hell this is, right? So to do it, again, line, these two lines here, loft. The more you do this, the more you get like an eye for this, and just see Boolean difference, just see what you need to create to carve your geometry. So for instance, here I will just create a 3-point box, move it out, move it down, so that I can get rid of this little lip here. Boolean difference, pum pum. Did I do it? Nope. Now I did it. There we go. So this is clean, this is fine, this is not fine. This area, I kind of want to have this fixed. Feel like we should have this fixed. Perhaps a fastest way would be to just kind of make a triangle here, like that. So it's not gonna have a uniform thickness, which is okay with me. Planar surface, so we create this kind of a triangle here. Just extrude it. Doesn't need to be full length. You don't need to make it attach while you're extruding, you can just then Control Shift select the surface and M enter, move it into the corner like that. Select the staircase and the surface, Boolean union, merge all coplanar. Okay, and at this point you have a staircase that is reasonable. I mean, of course you would want to create more details here and kind of get the top, you know. Right now it's a monolithic, you know, just concrete cast staircase, so of course you would want to add a little bit of detailing. One thing that I always love doing is chamfering the edges here, but I should not show you that. That would be bad, because at this stage you definitely don't want to chamfer anything. No, we'll keep that for most likely another course in general. That's going to be for 3D rendering course in the future. So let's show and let's position the stair inside of our building. So let me select the stuff that I don't really care for, like that, and hide it. The landscape as well, that goes away. Let's turn on our make 2D lines so that I have somewhere to copy the stairs from or move the stairs from. And as per usual, same points. You always use the same reference points for moving stuff into the correct place. And I love working separately on, you know, on top of a drawing and then moving stuff inside of my 3D model, simply because it lets me focus on the object itself. Okay, you can see that our stairs, they don't reach where we want them to reach. Also, let me show selected and just choose the floor slab, just the floor slab, just the bottom floor slab to show it. And again, the stairs, they don't reach. What do we do? Well, that's what I was talking about before. Bounding box. We create a bounding box, and now it's a little bit yucky, a little bit tricky to see. So let me hide a bunch of stuff. I select the walls, I hide the walls, I hide the bottom floor slab, I hide these walls. All I have is this box, the bounding box, and the staircase. I select both of them. And I scale 1D, not just scale 1D. And you always select the bottom point, any bottom point of the box, and you select the top point, corresponding top point of the box. And then you snap the scale to, you know, the top of the floor slab. Just like that. Now you can delete. And now you can see that your platform right here aligns with the floor slab here. If you want it to actually be a step here as well, you can lower the whole thing by just scaling down the box a bit and then using it to snap, but I think this is fine. Double check so that we're not crazy with distance. This should be below 0.2 meters. Okay, it's 18 centimeters in step height and 20, or sorry, I did 30 centimeters in step width. No, not width, like depth. Step depth is 30. So 30 by 18. I feel like that's reasonable, that's usable. A little bit on the big side, but hey, it is what it is. So we have ourselves a staircase, no tutorial on railings. We are not doing that. Now I'll just type in show to show everything. The guiding landscape, we don't need it, so let me do landscape NURBS, hide that. And just take a gander at what we have created. Let's do a clipping plane, just to see better. All right. So that's our staircase. That's our volumes. Awesome. Now, let's create a few windows and a door, I guess. A few doors, actually. So I'll start by creating them in... Oh my god, I keep doing this. Okay, hide the landscape, turn on the make 2D. I'll start by just making a door here and here, and then moving them into the correct place in the 3D model, or you can just choose to work on the 3D model, inside of the 3D model, I mean. That's up to you. It's as easy as just creating a box, like that, 3-point box. Along the line, you just specify the width of the door, 900 millimeters. Click. You specify the, well, I guess that's the length, and this is gonna be the width of the door opening, and then the height of the door opening. So we're just making a box, nothing fancy. 2.4 meters, like let's do a fancy one, 2400. Something like that. And congratulations, you have what's going to be in the future, a door opening. I'm just going to mirror it to the other side because I talked about having a walk-through hallway like that. So I'm just mirroring and I'm snapping to the midpoint here. Let me actually repeat that. I select the object, type in mirror. Right now mirror command is running. I snap to the middle point, and since my building is aligned with X, Y, Z, with Y axis actually, while I have orthographic snapping turned on, I can easily align my axis with the Y axis of the world. So I do that and then just click, and now my second kind of future Boolean difference object is on the other side of the volume. Then I'll select both of them. I'll give them a little bit of a breathing room away from this wall right here. So I'll just move them by, let's say, let's give it like 500 millimeters, not more. No need for more. And then just select your outer wall, Boolean difference. With the two volumes, delete the volumes, and you have wall openings. There are more parametric ways of how you can create a wall opening. If I remember, there's like opening. No. A hole? Place hole? Yeah, there's like the place hole variant to this, where you kind of draw a curve on top of the wall, and then you can say that that curve is making a hole in the wall. But I prefer doing it a little bit more destructive, but I mean, you know, I don't need to deal with, oh, I must not forget to lock the curves or else I might mess up the window, you know, in the long run. So keep that in mind. Speaking of which, the windows. Let's do something fun. Let's do a circular window. That's always fun. Would it look good? Window here, long ass window here, long ass window here. No, circular. Nah, let's not do or actually, yeah, sure, why not? Let's do circular windows. Right, because it's going to have exactly the same aesthetic, or not aesthetic. It's the aesthetic is going to be different. It's going to have exactly the same set of tools that we're going to be using for the window, be it a circular or rectangular. So a circular window it is. To make a circular window, we first need to draw a circle. And we need to specify how big that circle is. So let's say 1,500. No, yes, 1,500 millimeters. That's gonna be a big ass window, but we're happy with it. Oh yeah, and I did it too fast. Let me redo. There we go. So once you have that that opening, or not opening, but the outer window thing, all you need to do is just kind of rotate it 90 degrees so that it aligns with either one of the walls. Doesn't really matter, and you have yourself, you know, a vertical hole, future hole that is waiting to be placed on top of a surface, of any surface. So how do you actually center this circle on top of this surface? Many ways, so many ways. The easiest one for any rectangular surface is just getting a diagonal, so just drawing a diagonal curve and getting the middle point of the diagonal curve, like that. That is the middle of the surface. How do you get the middle of a circle? Well, that's the center snap right here, center point snap. So now as I select a window or the curve of a circle and type in M, enter, short for move, you can see that it really wants to snap to the middle, to the center point. So we let it. We move it from its center point and we move it on top of this the center of the diagonal or midpoint of the diagonal, like that. And now it's placed properly. Easy as that. Now to place it right here on this crooked surface, that's by the way the reason why I kind of twisted one of the volumes, so that I have a surface that is not aligning with XYZ axes. I will just take this curve here, or the circle here, and I'll just draw a line. Just like that. Trust me on this. There are, by the way, many ways of how you can do it. This is just one of them. I feel like this one is the easiest to use for new users, so that's why I'm doing this. So you just draw from middle point and you align it so that it crosses either on this side or on this side, but it needs to be like a horizontal line. Once you've done that, you just select both of them, move, enter, from this point to wherever you want on any of the edges here, doesn't matter. Right? But this point needs to be snapped to any of the corners along here. Right? Now we need to orient this circle to be on top of the surface. So I'm just going to select this, rotate, right? From this middle point. That's, by the way, why I chose this to draw this line here. We say that we will rotate from the end point of this line onto here, right? So we're forcing that it aligns with the edge right there. After this is done, now it's just the time to position the circle in the middle of this wall. So how do we do that? Well, same way we did the previous one, diagonal, select the circle, move from the corner point here to the diagonal midpoint here, we're done. Okay. That took a while. With rectangular parts it's a little bit easier because you can use three point boxes and so on, but hey, whatever works, right? Now let's add some not thickness, let's make these into an actual holes. So as I mentioned before, you can do place hole command and you can select the circle, select the base point, I don't remember, yeah, and then it kind of moves here. Yeah, it's a whole, apologies, it's so messy that I really don't want to teach you that. It's so much better to just take the freaking circle, change the gumball to be aligned to object, extrude the circle into the shape, let's change to ghosted preview. You can see the extrusion there. Let me move it out a bit. You just basically need to make sure that it's intersecting, right? Select the cylinder that you've extruded, cap it, type in cap, and then just use Boolean difference with this cylinder that is capped, and you get a hole. Same thing here. I'll do it fast now, just so that you don't think that it's like 5 minutes to do it. Wrong one. There we go. Okay, so you have 2 holes, right, in your building. Now it's time to make them into actual windows. You could draw, you know, partitions and so on, but I think it would look cooler without any partitions. So we're just going to do a simple version of this. Taking this circle that we still have on the facade, I'm just going to offset it by, let's go for 100 millimeters and make a planar surface in between the offset, like that. So select both curves and do a planar surface. It's going to create a ring for you, and then select this bad boy right here and planar surface only the inner curve to get the the surface for the glass. Then for the glass we will just actually first let's position these in the middle of the wall opening, I guess. So you can do that by just typing in M, enter, and just moving it back along this edge right here until you reach the midpoint, like so. And now it's time to extrude. So we select the frame, we extrude it by, well, we can do 200 millimeters or even more. I kind of want it to protrude a bit more, so let's do 250 millimeters, and the glass is 20 millimeters as per usual, and it gets moved inwards by 125, something like that. And again for this, and as per usual, I'll do this faster now. Offset 100. When I try to do it fast, I fail. Planar surface, move, fish out the midpoint. There it is. Don't remember what I used. I think it was 250. 20 for this, 125 for that. There we go. That's it. We have 2 windows. For the doors, it's also as simple as it is. I would suggest while you're just sketching, keeping them, you know, as holes. But if you just want to see like the facade enclosed, then just make a box. 3-point box works the best. And for the door, we just use 40 millimeters, right? Push them in a little bit, like 20 millimeters in to get that little lip. And that's it. That's enough to get the doors. Remember, we're what's the word? Symmetrical. We're symmetrical in this building with these 2 openings, so I can just mirror midpoint to the other side. We're done. Now for these geometries, they are in the stairs layer. I don't want that, so I'm just going to create a new layer, call it window, create a sub layer for it, call it frame, another layer in the window main layer, call it glass. While I have window layer selected, if I choose new layer, it's going to actually create, it's not going to create a layer inside of the window main layer. It's going to create a separate one. I'll call it doors. Now let's place stuff. Doors, right click, change object layer, windows. First of all, let's go for frames, this and this. No, that's a curve. That's my bad. There we go, frames. Change object layer, glass, change object layer. That should be it. Now we can hide the glass. Yep. We can hide the doors. Yep. Stairs stay, stairs can be hidden as well. Okay, everything is in order. So currently, oh, we don't need the helper lines anymore. I can delete that layer altogether. For sub D, that's our landscape with our building sitting in the landscape. So now I want to actually, let's make a small little terrace here, perhaps, or not really. Yeah, I think we can. So let's do a small little kind of entrance area here. And I'll do it by actually just taking this line, because, or actually Control Shift select the edge, dupe edge, duplicate edge to get the line here, move the line along the edge here. And this is, by the way, why I hate the center snap. Notice how it's just snapping all over the place. That's why I always have it turned off unless I'm dealing with unless I'm specifically working with a window. And let's just do something like so, and perhaps make a copy of it, position it here along this edge, so we end up having these two lines. Let's loft between them, or actually, do we loft or do we make them bigger? No, we don't need them bigger, so I'll loft between them immediately. That's gonna be our terrace, by the way, or entrance porch thing. So we have a surface, we position the surface, move, enter, V, enter, right here, right about here. And we extrude it down by minus whatever it is, 500. That was the incorrect direction. So move it by minus 500. Something like that. This seems very awkward, but we can fix it by just simply taking this edge right here and just moving it up. I'm just going to align to C-plane. Yeah. So we do a little bit of groundwork to get this terrace going. So now we have kind of a little bit of a projection here going on. I feel like I feel like this would be appropriate. So I just Control Shift selected the surface and extruded, but I apologize. I caught myself that I'm already, you know, I'm designing again. I should stop doing that. God damn it. Okay, let's stop here. This is going to be saved as stage number 3, and then we will continue on from here with stage number 4. Okay, let's continue on with our little design, and this is stage 4. So the file that you will see after, you know, this stage is going to be stage 4. Stage 3 is basically where we left off, right? So currently I am going to be working on stage 4 file. That's what I meant. Anyway, I have added a few windows, a few smaller architectural elements to the building envelope just to make it a little bit more interesting. All of the tools used here are exactly the same tools that I've shown before during the overall modeling process. So it's nothing new, same techniques. Just so that we cover all of our bases, I wanted to also talk about curvilinear stuff and curvilinear geometry, because right now, even though in architecture most of the time you are dealing with something like this, you know, quite rectilinear aligned surfaces and so on, just because of the you know, how the building industry works, and this kind of a means of producing economically sustainable buildings is usually based on like rectilinear geometry. But if you want to make curvilinear stuff, that is absolutely possible to do in Rhino. So I just wanted to show you like a pretty quick example of it. And it's going to contain basically 3 floor slabs that are kind of interconnected, or that are looping from one floor slab to the other in a smooth way. So I will show it to you by just first of all drawing 4 or 3 rectangles. Actually, it's going to be 4, but so 1 rectangle, 2, and I'm not going to be at scale or anything else, just to show you one tool that might help out when creating curvilinear forms. Everything else is, you know, the loft and the planar surface and so on. It works on both rectilinear and curvilinear, so it's, if you know how to make this, you will know how to make a rounded version of this. But in terms of a smooth transition based geometry, that is a bit harder to do. That's why I'm showing it to you with rectangles. So I drew a rectangle right here. I copied it and I moved it up a bit, and I can even have it a little bit at an angle. Let's have 2 of them here actually. So I made a copy here, and I will make another copy and move it somewhere here. So we have 4 rectangles. Lowest one, 2 in the middle in terms of height, and one the highest one. Right? Now I'm going to select all 4 of them and type in planar surface to make them into surfaces, and just hit delete to get rid of the curves. So now these are 4 surfaces. How do I make this a continuous shape? Well, blend SRF, blend surface, is your friend to be able to do that. Blend SRF. It asks you to select edges, so I can say, okay, blend me a surface between this edge and this edge right here. And it's gonna do exactly that. It just simply takes the surfaces, the 2 surfaces, and creates a surface in between that blends perfectly from one to the other. And you can choose the type of surface that you want to create. It's either curvature. If you just choose position, it's just going to create a loft. You don't want that. You want it to be either tangency or curvature based. I prefer to use curvature. Hit OK, and now we have a pretty smooth blend, right? Let me just push this out a bit more so that the blend is not so intense, and try that again. Blend surface. If this happens, you can always wait, let's cancel and let's try again. Blend surface. You do need to select the 2 surfaces or the 2 edges on their respective ends, right? So if you're selecting this end and you would be selecting this end, then it would make the cross surface, as you see the ribbon type of a surface. So make sure that you're selecting them properly. Hit OK. Now we have a blend. Let's do the same thing for these 2. A blend here, and same thing for these 2. A blend here. Right? So now you end up with having something like this. But wait, there's more. What if you actually want these 2 ribbons to be blended completely into one surface? You can do that as well, right? So let's give it a little bit of a gap, and let's use another tool that's called merge surface. Merge SRF. It only is able to merge 2 surfaces at a time, so we'll need to take our time doing this, and the surfaces need to meet perfectly to be able to be merged. I guess I said that correctly. So we just select one surface, second, and they become one. enter one surface, second. This is not like join. It actually rebuilds the geometry to be a continuous single surface rather than a poly surface made out of multiple surfaces. Same thing here, merge, merge. Now we have two of them, and now I can use blend surface and just blend between this edge and this edge to get something like that. Join it up. And now we're getting to, you know, a pretty fancy curvilinear form. Then for this form, I can use offset surface and give it like a 500 millimeter thickness. Then we need to give it a little bit of time because it takes a while to generate the offset for this. You can see how heavy it gets. If it gets too heavy, by the way, let me undo. Offset surface, I believe here, instead of round corner, you can use sharp corner, but I wonder if you can change geometry here. I guess you can't. Okay, so that is the trade-off. That is the problem with offset surface as it is right now. One suggestion would be, one tip would be, but because just so that we're clear, if we choose Arctic surface or if we choose EMAP, it's super smooth, it's super clean, right? It's just, it has a lot of information in it. So if it gets too heavy for your computer, you can always, instead of offsetting a poly surface, you can always let's make a copy, select the shape, convert to a sub-D geometry, and a fast way of doing it is just using a quad remesh component, quad remesh, and choosing how many sub-D patches or sub-D faces do you want. In this case, 2000 is way too much. Let's do 500. Preview. That seems like it's fine. Perhaps even less. Let's try doing 100. Yep, 100 should do the trick. Make sure to convert to sub-D. Hit OK. Or delete input object so that it gets rid of the original. Hit OK. And now that's your sub-D. And the reason why we use sub-D is because now we can just use offset sub-D, solid yes, distance 500, both sides no, delete input yes. And now this is a sub-D form, which, as you can see, it's instant, it's real time. If I were to EMAP this as well, you can see that virtually it's exactly the same in terms of geometry as what we've had with this surface. The only problem is that with sub-D, you're losing a little bit of information in regards to the surfaces themselves. It's going to, once we convert the sub-D to NURBS, that's the command, delete input objects yes, hit OK. Then you can see that these are the patches 1, 2, 3, 4, 5, 6, 7, 8. 8 patches that we're getting, while here we're only dealing with 3 patches. So basically you have more subdivisions here when you're converting, when you're using the sub-D route of kind of thickening the geometry. But honestly, sometimes you do have to take the sub-D route just to be able to produce pretty accurate curvilinear thing. So that was like a small tangent towards curvilinear forms. I would strongly suggest that you first master creation of rectilinear shapes in Rhino and then move into curvilinear form generation, simply because then you will be controlling the form and it won't be other way around. So you need to know your fundamentals to be able to really go deep into geometry creation or complex geometry creation in Rhino. Okay, with that out of the way, let's start creating drawings. So first things first, I don't really need, one second, the NURBS landscape anymore. You know, this was the guide surface that we've created from the ISO curves that we had. I will delete this just so that it's not in the way, and I will delete the layer as well. These guide curves, all of these, we don't really need these anymore as well. So I'm thinking of getting rid of them. Yep, because we're going to be generating our own guide curves. So I will be deleting this. In terms of trees, we might want to take a look at the trees. Nah, doesn't matter. Representation of trees would just be cylinders in a Rhino file, so we don't deal with that. That is too not advanced enough, I think. Make 2D, that layer gets deleted. All of the stuff within that layer gets deleted. Building volume, that's an empty layer. Layer 0, empty. I'm basically just deleting all of the layers that are empty. By the way, there's a faster way of doing that. If you type in purge, P-U-R-G-E, purge, you can choose to delete all of the layers. Yeah, layers that are empty. Enter. And I'm not sure if it deleted any. I think it did, but now we're left with the sub-D landscape, the slabs layer, the walls layer, the stair layer, windows layer, and doors layer. All of these I will be placing into one big master layer called, so new layer called 3D. Well, capital D, 3D. I'll just select all of these layers and just drag them into the 3D layer like that, so that I can easily turn on and turn off the 3D layer once I have more in here. Structuring your file is very important, and cleaning it up constantly is very important during the process, the design process. Okay, time to create the drawings. So I'm going to make a clipping plane. First corner of rectangle. Okay. Oh, sorry. Almost forgot. A very important, or actually, 1 second, I need to plan out how I'm going to teach this. The contour lines, I'm thinking about the contour lines of the landscape. When do we do this? No, we will add them as an additional layer on top. So layer, we are creating a clipping plane. So type in clipping plane, click in the corner of your floor slab so that we start cutting from it. Just like that. That's our clipping plane. And move it up, gumball, align to C plane, move it up by 800 millimeters. I don't know what's the regulation in your country. Let's say 800 millimeters above the floor slab, right? This is going to be how the site looks like. Not the site, sorry, how the building looks like as it's being clipped at that particular height. And then as per usual, we select the clipping plane, we go to its properties, and we choose top to be clipped as well, because that is indeed going to be the projection that we will be clipping. I will select it. I will type in, select everything basically. Type in make 2D. Yeah, that seems fine. Layer name, floor 1. Hit OK. That's done. Let's position it here for now. Then we take our clipping plane, we move it up. Well, actually, I should probably move enter, V enter, move vertical, and move it until it reaches the top of the second floor slab and move it up by 800 again, so that it clips. Again, selecting everything, make 2D, floor 2. All of the settings are the same. That's our second plan. Now for the sections, I will decide on the sections according to the plans. So I'll actually draw out the section markups or just section lines in the plans, and I'll position the clipping plane accordingly. So I want to cut through the staircase in both cases. So through the staircase here and through the staircase like so. Come on, there we go. So these are going to be 2 alignments that I will use for my sections. I can actually take this, copy, and copy it onto my... Oh, why is that so... Oh, that's the windows. Copy that right here, right? So how do we deal with this in the 3D model? How do we generate according to these section lines? Well, we just, in the perspective view, we create a clipping plane again. I could have used the same one. I apologize. I will go to the properties of the clipping plane and turn it off so that it doesn't clip stuff. It's easier to orient it. I'll move it to the clipping line or whatever it's called right here, and I'll just kind of rotate it so that it aligns properly. And again, move, copy, or not copy, sorry. Move from point to point so that basically we're now cutting and we're looking towards, towards the right in this case. Then, as per usual, we copy from the corner to the corner right there, the corresponding corner. So we have, oh, I don't need the original one, so I'll delete it. So we have a clipping plane right here. Now I can turn it on, and this is what it's going to see. Well, how do we look at the projection of this clipping plane? Right? How do we look at the... Right now we see it as a perspective view. How do we see it as a 3D view? Well, you need to do 2 things. You need to rotate the whole world or the C-plane onto the clipping plane, and then you need to look at a plan of that C-plane. So remember that grid that I will have troubles finding? It's right there. This grid, which corresponds to X, Y angle, the world position, that can be adjusted. So we need to adjust it so that it corresponds to, this is the origin of the world, and the X is going along the bottom edge of the clipping plane, and the Y is going along the vertical left edge of the clipping plane. How do you do that? You go to C-planes, here in the top, C-planes, and you choose 3-point C-plane. Set C-plane by 3 points. You choose that. You click, it asks you for the origin. That's always bottom left of the clipping plane as you're looking in the same direction as the clipping plane is looking at, right? So this little stick matters. So bottom left, then bottom right. In doing so, you're defining what's the new X axis. Top left, you're defining the Y axis. So X, Y, it calculates the Z automatically, and you can see now there's a little grid here that basically says, okay, that's the new world. By the way, if you start creating boxes now, it actually creates them in this particular C-plane, right? So that's kind of neat. Okay, enough about that. How do you look at it in a plan view? So we kind of need to now, since we have the C-plane, we want to see the top view of the C-plane, which is going to be our section. I know it's convoluted. You get used to it in one project. Afterwards, it's just fine. It's not a big deal. So C-plane of the plan view of the C-plane. You just type in plan. enter. That's as easy as that. You have your plan view, you select your objects, you type in make 2D. We call this section 1 or section AA. Hit OK. Generates the section. We drag it out to, you know, wherever you want it to be. Let's say here. There's our section. We'll clean it up. And that's it. Now you have your section done. If you want to save this view so that you don't need to do the weird C-plane thing anymore, next time you need to access this view, you can do the named views, or named view command, and just save it here. Save. And just call it section AA. There we go. Now that's your section. And you can see that it's even, and every time you want to access it, you just do named views and you just double click on the name of it. You can see that section AA is your current view and you can't really rotate out of it. So you've lost your perspective view. How do you get it back? Well, you click the small little arrow here, set view, perspective. You're back in your perspective view. And you say, oh, I forgot one thing about the section view. You just double click on that, you're back in the section view. And then set view, perspective, you're back in perspective. So you switch between those. Usually I have multiple views saved here and I just jump between them through this menu, right? But named views, typically I have it turned off, and when I need to, I just type in named view and then jump and turn it off again, because real estate of the screen is important. Okay, we have our clipping plane here doing its thing. We're done with that section. We want another section. How do we work on it? Well, perspective view, turn that bit off, move from this point to this point, rotate, so we align it. Oh, rotation will not work. I forgot to mention, I'm sorry. Forgot to mention important thing. The clipping plane, the C plane, it's not the clipping plane, the construction plane is still oriented weird. You want to orient it back to being like a normal world XYZ. A button that does this is right here. Set C plane world top. You click it, now you're back to normal. Don't forget to click that button or else it's gonna be a pain in the ass. Okay, now as you're back to normal with the clipping plane, we can do rotate 3D, or sorry, just rotate around this point and we just align it. Just like that. And as per usual, we move it from corner to corner to the correct position and make it start cutting again, like that. Now I kind of want to, not kind of, now we will be creating the C-plane again. So 3-point C-plane, as per usual, bottom left. I can't snap to it. Hello, Rhino, please. Yeah, there we go. Bottom left corner. Bottom right corner, again, I can't snap to it. What's going on? What the hell is going on? Hello? Bottom right, please. Smart track, maybe? Feels like something's funky. Okay, if snapping is not working, you can just leave the end snap turned on and have all of the other snaps. No, this is weird. X-axis. Okay, let's escape out of this and try again. C-plane, or rather C-plane 3 points. This one, this icon right here. Try again. Yeah, it's bugging out. This is what it is. Let's have that selected so it doesn't snap to this. Okay, sure. It might be because we're too close to the building with our C-plane, with our clipping plane. So I'm just going to move enter this away. So how do we do that? Let's not clip and just kind of move it from here to here. It is not moving. There we go. Now this is most definitely a bug. I am just sliding it, by the way, along its plane. I'm not kind of pushing and pulling on it. So technically, since clipping plane is infinite, it will not affect the section at all. But now, once I start actually clipping the perspective, now it should be much easier to snap to the points. I hope this is going to be fixed, because this is awkward. Okay, where were we? C-plane. C-plane 3 points. Please work. There we go. Bottom. Oh my god. It doesn't want to. The struggle. Okay. If that happens, then it's most likely the clipping itself that's messing you up. So let's not have clipping and let's just do it this way. 1, 2, 3. That was super easy. So it was the clipping plane being turned on. It didn't like with the snapping. If I remember correctly, Rhino 8 fixes this problem. Yes, Rhino 8 in the patch notes, they say that the clipping plane snapping is fixed. So if you have Rhino 8 and you're watching this in the future, you will not have this problem and you will be confused why I have this problem. Anyway, I have created this C-plane here. First point, second point, third point. And now I will turn on the clipping and I will type in plan. So I look at it, I select my whole thing, there we go, and type in make 2D. Make 2D, clipping plane intersections turned on, BB, section BB, hit OK. There we go. Let's go back to the top view. We have our section BB, and that is going to be that. A facade is literally just a section that is not cutting through the building, right? So if you know how to do sections, you know how to do a facade. A side plan is just a top view, like it's just this, make 2D. That's the side plan. It's basically a plan with no clipping plane, right? So we're not going to be dealing with the side plan. Let's get rid. Oh, actually, while we're here, while we're in this view, named views or named view, save this as section BB, so that we can jump between section AA, section BB, right? As we please. Delete the clipping plane. What else do we do? We need to convert this back to set view, perspective. There we go. And now we can start working on the drawings. So the way you work on the drawings in Rhino is pretty straightforward. We have created these main layers here for floors. We have created the 2 layers for each visible sublayer, clipping plane intersections and curves. These are where the cross section or the sections happen, and this is just the projection of lines that you see in the background of the section. So I always like to have my clipping plane intersections red, and that's what I'm going to be doing right now. I'm just converting all of them to red color, just like that. And now it's time to start hatching things and cleaning things up. So where do we begin? I guess we can begin by me showing you how to hatch. Well, you do need to create a new layer, and I will be lazy and I'll just create a new layer just in general right here and call it hatch. And this layer will be applied to every single drawing here. Should be fine, right? So we hatch, make it my active layer, make it, let's go for blue, like that. And let's keep these layers expanded so that I can easily select, right click, select clipping plane intersections, right click, select objects. There we go. It selects all of these objects right here that you can see. I don't need this one because this one is just the staircase, but all of these I want to hatch. So I type in hatch. It asks me to click inside the regions which I want to hatch. So it's gonna be inside of the walls. I purposely choose not to hatch the doors, for instance, or the windows, just because the lines are already pretty close next to each other, so I don't want to get too heavy of a hatch. Once I hit enter, then it asks me, okay, what kind of a fill for a hatch do you want? Do you want an angled one? This is not angled at all. What the hell? Or let me guess, it's angled, but yep. But you really need to zoom in. So if this happens, just increase the scale. 100, 1000 actually. And rotation 45, you know, concrete stuff. In this case, I'll just use a solid fill, hit OK. Now we have our hatch. Same thing here. Actually, I'm just going to do it this way. Select objects, select objects, select objects. I'll just hatch it for every single drawing at the same time. Hatch. Click, click, click. Give me a second. This should be pretty fast. Go by pretty fast, I mean. That's our staircase coming along. This should be trimmed off, of course, but it is what it is, I guess. Yeah, I should be trimming that one off. Because it's basically because I left the landscape. Oops, that was a mistake. Did I mess it up? I messed it up, didn't I? That's fine. That is still correct. Okay. How does this look like? This is a terrace, so that's correct. There. I'm very confused about this one. Oh, that's the wall. The outer wall. Okay, and that's the staircase. Now we're back on track. If you want to, you can do hatching in 2 steps. That's absolutely acceptable. For instance here, right? So I'll just select this area here, make sure that you have a completely enclosed volume and you hatch it separately. So I'm just gonna go around, see if I missed anything. Doesn't feel like I have. Actually, this one perhaps should not be hatched because it's just a separator not separator, railing. It's just a railing wall, so I assume we had to just cut above it slightly. So I'm going to select this particular hatch and undo it. So what I want to do with the railing, I'll lie about it and I'll just say that it's actually in in floor 2. It actually belongs to the curves layer, not the clipping plane intersection, so that we are actually not cutting through it. We're only cutting through the outer envelope. And I'll hatch this one. Just like that. Okay, sorry for the wait. Now, in terms of cleaning this up, it's mostly just selecting stuff and deleting stuff. Right, so everything that is below the section, the landscape section line needs to be deleted naturally. And that was an ugly line right there. This seems to be okay. This is bad. Good enough. And then for this one, I would argue that this doesn't give any additional information, so we just get rid of it. Sure. I'm just literally deleting the lines. Like that, up. That line is necessary, so we just take this to trim. Okay, so that's the initial cleanup that we do. This is very convoluted, so I'm just going to in section BB, probably no, sorry, section AA, I'm going to hide the clipping plane intersections, and I'll just delete this line in particular and this one as well. Yeah, sure, I'll delete both of them just to keep things a little bit cleaner. So you can be quite selective as to what you actually keep in terms of the background graphics. These can also be we can get rid of these as well. Okay, so that's that in terms of the initial cleanup. Now I'll show you how you can import or not import, but generate ISO curves and place them on top of your landscape. That is actually pretty easy. All you need to do is just take this geometry that you have. I'll just create a new layer, call it landscape ISO curves. Zoom into the landscape. And let's start, oh yeah, I forgot. I keep forgetting to fix the C-plane. So if you still have your C-plane messed up, don't forget to go to C-planes and set it to world top. So this button right here, it's important. don't forget about it. Okay. So contours. Contour lines for the landscape. I will just create a bounding box around the landscape. I like creating bounding boxes because it always shows me the most lowest point of any geometry. I'll make landscape isocurves my active layer, and I'll just type in, while I have the landscape selected, I'll type in contour. Contour. It asks me for the base point. Sure, that's the lowest point on the box. Asks me for direction, that's going to be the highest point of the box, and asks me for what's the step size between the contours. As per usual, we do 500 millimeters. Enter. We get ourselves some contours in here. Let's make it prettier. Let's not do 500, let's do 250 millimeters. That is the wrong thing to contour. Don't forget to select the landscape and contour the landscape and not the box. Wait, did I mess it up? From here to here, 250. Ah, there we go. So some nice little contours here. That's all you need. Don't forget to just group them up. So type in group so that they're all in the same group, like so. Right, and then I will just take a point right here and I'll place a point on the corner here. Remember, this is our trusty corner that we use to migrate things from one place to the other. So this is just, we know where this point exists in every single plan drawing that we have. That's why I'm using it. Now I'll select the contours and I'll select the point, and holding down the Alt key, I'll copy them to the side like so. And I'll scale the whole thing down along the Z axis down to 0. Just like that. And now we have a flat drawing, right? So now the next step is to actually select this, type in copy, and copy it from this point, or don't forget to tick mark the point snapping in the object snap rollout, point snapping. So we copy from point to this endpoint right here. And we get our beautiful contours in here. Some of them will need to be deleted, but others, they stay. So like that. And then we just kind of do it all over again for here. Okay. The contours need to be, of course, treated because the building is in the way. Let's go to the top view. Let's get rid of the of these contours right here. Get rid of the points, or rather the point. Let's select the contours, ungroup them. Actually, let's change the isocurves layer to like green, something like that. Delete the ones that are here because we're cutting through the landscape in this place. And then we just need to basically get rid of the contours that go inside of the building, right? As easy as that. So I'm just going to choose clipping plane intersections for floor 1, select objects, type in trim, and go to town, trimming the contours like that. Hatch is in the way, so I'm going to hide the hatch layer so that it's easier to trim like that. Is there anything else here? Not really. Okay. And then this line right here, this is our little terrace that also trims away the contours. So I'm just going to do something like so. Technically, like the clean way would be to get the contour to follow here, but we're not doing that because that would mean that we would need to dig a hole in the landscape, and we didn't do that because this is still like a pretty early stage project, right? Okay, so that's cleaned. Let's do the same thing for floor 2. Actually, I'll select all of it like that. Trim. And let's go to town on these contours. That one. Okay, this is clean. This gets gotten. This gets deleted. There we go. Trimming is fun. I'm having fun. I have like an anecdote while I'm doing this. Not an anecdote, well, a story. Or certain information. I did not a live stream, but a video, a YouTube video, where I did any percent speed run of an architectural proposal while using Rhino. And basically just to check, just to test how long does it take to produce an like a proper architectural proposal for a client, by the way, in Rhino. And it takes, to get everything, including renders, drawings, the whole thing, the whole kind of package, it takes 11 hours to do. I think we can drop it down to like below 10 hours if we really push for it. So it's not like this is a very long and very difficult process. It's as difficult as you make it. That's what I wanted to say. Okay, we are done with the contours. I would start numbering them, but we'll just do much simpler text annotations later down the line. In terms of here, we could kind of clean up a bit more. Now just kind of get rid of certain parts here. Trim. Come on, trim, go away. Trim, go away. Like that. This needs to kind of extend and then get trimmed off. Okay, that's good enough. We have hatches to hide our crimes. So we're fine. Okay, how do you add text and markups? Well, the markups you just kind of draw yourself. I'll just make a new layer, call it text, or we can just assume that text equals markups. And let's draw a few lines. So first of all, the section markups, because sections right now are very ugly. So let's make nicer ones. I'll just draw a straight line. Let's do a near point snap. Straight line like so. You can't really see it. Let me delete the line so that you can see it better. Let's offset it. Let's say 300, something like that. Let's do a midpoint snap. So let's do a triangle like that. The triangle's a little bit too big, so I'll scale 1D from here to here, something like that. And that's a nice little triangle for, you know, to mark out where the section is taking place. I think we should move it closer to, let's get it back on track. It went right through the middle of the staircase, so it's easy to create a line like so and just move it closer to the building. Let's see, somewhere here. Well, I'm an undecided bastard. Okay, somewhere here, like that. And we will name this. So this is for section BB, so there needs to be a letter B here. Well, we just type in text, which opens up this text rollout here. You can choose the different styles, different heights, different fonts, and so on. If you want a predetermined style for the text, then you first need to create it. So under, I'm not going to be creating it, but I just want to kind of show to you where you can do it. So it's under, not mesh, drafting. It's under drafting. I believe I only use the edit text, find text, annotation. I think it's under annotation styles, isn't it? So I think it's this button. Annotation styles. Okay, there's not even a tool for that. We just click annotation styles right here. It opens up this document properties tab. You can also type in properties and it's going to open it up as well, or options. And for annotation styles, you can create more than one annotations. You can also create more than, wait, where was it? 1 second. Yeah, it is here, isn't it? Yeah, so for annotation styles, you can create a new one, template, millimeter large, hit OK, click edit, name it to markup text, or sorry, markup annotation, and change the the different kind of fonts and so on here. We will come back to this later once we deal with dimensions. For now, for the text, I just kind of go for text. You can see that now I can change between these two. So we will just use for default style B, font Arial black. I want it pretty bold, Arial black. And then for the size in millimeters, let's do 300. Hit OK. That's my letter B. Let's make it bigger. You can rotate it. And at this point, I will not be very accurate with it. So I'll just have it this way. I'll group it up and I'll just copy it or mirror it to the other side of the drawing. Mirror. Let's say this is my mirror line and it's now here. To get it to the other drawing, we just copy. Or actually, we need to do AA as well. So let's do that. I'll just, holding down the Alt key, I'll just make a copy, move it to anywhere on this line, rotate so that it is aligned. Also, make sure that you're looking at the correct direction. Are we? Yes, we are. Okay. So here as well, I'll ungroup so that I am able to select the text, double click on the text to edit it, and type in A. Then select the whole thing again, group. And that's it. Now you can just have this closer, hold the Alt key to copy it over somewhere here, and get all 4 of these annotation things and just copy them over to this drawing right here. From here to here. This one is ugly, so let's move it out of the way a bit. There we go. All others fit well. So that's done. Now, as I was doing this, I remembered that we forgot to mark out where the cantilever is. So I need a dashed line on top of here showing where this building area or part of the building sticks out here and creates a cantilevered, overhang. So I'll just create a new layer, call it dashed line. Let's make it like orange. Sure, why not? Orange line, that's dashed, that is going to be dashed once we're done with it. I'll just create a rectangle here of my cantilevered area, like so. Do we need to do... No, we don't need to do anything else with that. Move it from this corner point to this corner point, you know the drill. At this point, we select these 2 lines because then we will use trim away this. So this is our cantilevered form right here. The staircase though, I'm going to get rid of the staircase in the first floor because we'll be using the staircase from the second floor right here. Make a copy of them. Get them in here. That is fine actually, because all of this area is going to be cut at the 4th step, right? So all of these are actually dashed lines, including a line right here, or to be clean, we need to kind of do a line all the way through here. And it's going to get cut right here, right? So that is going to be in our floor 1, clipping plane intersections. This is very AutoCAD-y, isn't it? This becomes dashed, right? And that's it. Now for the text, we just create a small little arrow. Should probably explode this, mirror this, just like that. Trim, and there we go. We have ourselves a little arrow here. That's that. Now in terms of creating arrows here, I will actually just borrow this one. Down to here. And down to actually here, because this is mostly aligned with the floor slab. Rotate from here to here to here. Grab the control point and just move enter to the midpoint here. Grab the control point, move enter to the midpoint here. That's it. We have ourselves a staircase and a very, very empty empty plan here and empty plan there, but hey, it works, right? And also two areas that are impossible to access. In terms of the section, I don't really want to do much. The altitudes, you know, we would kind of add altitudes, but we will not be doing those because you just draw them and you write the text. Now, in terms of the measurements, it's time to actually add the measurements to our drawing. 1 second. Measurements. I needed some coffee for that. Let's create a new layer. Call it dimensions. Dimensions. Make it our active layer. I'll give it like aquamarine. No. What kind of color? Lavender. Sure. Lavender color for measurements. And we'll start adding them, right? So there will not be too many measurements here. I just want to kind of showcase them, how you can add them, but you know, for something like this, usually you don't have them, but just so that we don't just miss the whole portion of it, and so I can teach it to you, we will be doing them. So you can add measurements through the drafting tab right here. Dimensions, sorry, not measurements, dimensions. Linear dimension, horizontal, aligned. These are the main ones that we use. The linear dimension for stuff that is aligned with XY angles, and aligned dimension for something that is, you know, a little bit more crooked, a little bit funky. So if I were to just create a linear dimension right now, it creates exactly how you would envision it creating in AutoCAD. Click once, click twice, and drag out that dimension. And if I zoom in hard enough, I'll see the number. But it's pretty damn far. Or rather, it's pretty damn small. So we need to somehow fix it. The reason why it's so small is because we're drawing everything in millimeters, and it's expecting that when you're dealing in millimeters, you're probably creating something small, but we're not. So all of the measurements are messed up. We need to make our own. If I type in options, I can take a look at what kind of annotation styles, under options, annotation styles, what kind of annotation styles I have. So we were using default as our default annotation style, right? And if I edit it, I can see that under font, the height of it is 1 millimeter. That ain't good. So we need to make our own. If I just go to markup annotation right here that we had, you can see that the height is 3.5 millimeters, but the model space scale is set to 100. That is better. How do I explain this? I'm looking at my wife for influence. She's basically giving me the signs to end the tutorial today. But no, I'll keep going. Okay, so how do I explain this? Let me cancel this. Let's select the dimension and let's go to its properties. You can see here that this dimension has been created with the style set to default, and that actually happens. Let's delete. When you are creating the dimension, here annotation style is set to default, but you can change it to whatever style you want. For instance, markup annotation. Hit OK, and now as I drag it out, this is our style. So why did it suddenly become so much bigger, even though it still says that the text height is 3.5 millimeters. If I type in options, go to markup annotation, you can see here, font is Arial, height 3.5. That is because model space scale is set to be 100, 1 to 100, right? So it takes 3.5 millimeters and it actually scales it up by 100. So adjusted text height becomes 350 millimeters in the drawing, right? So this is, once we start adding annotations, we need to know what is going to be the scale of the drawing when we are going to be plotting it out, right? So for something like this, give me a second. 244 meters. So for 44 meters, 1 to 100 becomes 44 centimeters. And 44 centimeters doesn't fit inside of an A3, but almost doesn't fit, because A3 is 420 millimeters in length. So meaning that if we just cut away, just trim away parts of the landscape, we would be able to fit all of this on A3s at 1 to 100. So we are keeping the scale. So we remember, we're going to be using options. We're going to be using 1 to 100 scale. Okay, that is our annotation. By the way, let's make it fresh. Let's make it anew, just so that you're not confused. So let's have this, delete this, yes, and let's create a new, give it a name, or yeah, let's first select copy settings from template, millimeter architectural. That's perfect. And I'll just name this learn to annotate. Hit OK. That's our little annotation style. Let's edit it and see. So you can see that it's still 1 to 100 scale. Height of the text is set to 3. Font is Arial. I hate Arial font for the measurements. I prefer TXT. This one right here. Let me first show you the font. So let's hit apply, hit OK. And let me draw out the measurements. That is TXT font. This is very lightweight. It doesn't get in the way. And by default, the the architectural template annotations give you this, the architectural ticks for the measurements. So that's great. And also all of the kind of settings are already dialed in here quite nicely. So I won't go too deep into them. If you want to change, the arrow size of the text to something a little bit more reasonable, like 2 millimeters, and perhaps your text height needs to be a little bit smaller, also 2 millimeters, then you can do it here, hit apply. This updates automatically, right? So we have our little annotation situation going on here. And that means we can now just go to linear dimension and just go to town, applying different measurements. Does that even matter? Yeah, kind of does. Like that. Or actually, I probably need to get this measurement, or maybe I don't. So this is going to be borderline unreadable because we have lavender set to as our color. Let's change this to black so that it's a little bit easier to read, but you get the idea. For aligned measurements, all we need to do is just use aligned dimension. Make sure that your annotation style is set to learn to annotate, and yeah, we get the aligned dimensions here. That's a bad one. Let's do an interior one, like that. You can chain them as well. There's like, I don't remember. Yeah, it's align dimension continuous. If you right click, you can keep just connecting things, like chaining these. right? So you get measurements that way. Whew, okay, so measurements are, I think, covered. In general, they're exactly the same as what you would expect to get in AutoCAD, right? So if you have AutoCAD knowledge, then you will be able to work with this, right? Quite easily. There is one. Oh, this design is awesome. Oh my god. Okay. To be able to enter the balcony, we actually should most likely do something like this, right? And then we get a dashed line here. Let me just borrow these two lines, copy. I can't leave it like that. Copy, put it in there. Like so, that's perfect. So we actually only needed explode and select. We actually only needed this line and we will connect it to here. Yeah. Change. So that's a dashed line as well. Speaking of which, let's talk about line types. For instance, the dashed line. So here, even though it's, marked as dashed here, it doesn't really produce a dashed line. How do you do that? Well, it's also controlled through the layers as per usual. Under the line type right here, where it says continuous, you need to click it and you need to choose whatever the line type you want. If you want more than these line types, you can create your own by typing in options, going into line types, and here choosing to add a new line type, naming it Gediminas line. It's my name, by the way. Gediminas line, and giving it a pattern. So the pattern is in millimeters. Well, here you can see it. It's in millimeters, and you are specifying it. How do you explain this? You're specifying the line length, the gap length, the line length, the gap length, the line length. So if I say my pattern is 5, comma, not dot, comma, 1, comma, 5, comma, 2, it's going to give me a line that is 5 millimeters long, then a break that is 1 millimeter long, then a line that's 5 millimeters long, and a break that's 2 millimeters long. Then 5, 1, 5, 2, 5, 1, 5, 2, and so on, right? So I can generate any pattern I want. In this case, we kind of want just a dashed lines similar to this. So it's 5 by 5, and I will do exactly that. So let's do 5, comma 5. Except that mine will have a line type scale set to 100. Because I know that this is going to be my scale for plotting. So it's gonna be like 500 millimeters line and 500 millimeters gap in the drawing, right? So now under line type of the dashed layer, I can choose Gediminas line, this one, hit OK, and now you can see that it's, it just works. For the staircase, it looks like garbage, like hot garbage, so I will make it a little bit less beefy. Let's go to options, choose this, and instead of 5, 5, let's do 2, 2. Why not? 2, 2, hit OK. This is better. This is much better. Okay, so we have some dashed lines in our drawing. What else? I think it's time to talk about the plotting of things and exporting things. Finally, we can export this design, this beautiful, wonderful design, and then call it a day with the course itself. Well, we'll call it the course finished. So how do you export things? Or how do you not export things, but how do you extract PDF drawings out of, you know, your Rhino file? Well, you can either do it by just typing in print and printing to Adobe PDF if you have Adobe. If you don't, you can just use Rhino PDF and then setting up all of your settings here. But I think a much more professional way is to set up in Revit, they're called sheets. Here they are called layouts. So you can create layouts. The way you create them is by clicking this plus sign right here and choosing to create a new layout. Then we name our layout Plan 1. Plan 1, printer. It's gonna be Rhino PDF. For some reason, when I change this to Rhino PDF, it renames my layout to page 1. No. Plan 1, please. Size of the layout, I said it's gonna be A3. And for my plans, it's going to be vertical. So it's gonna be portrait mode. Initial detail count, this is basically how many drawings will you have in your layout? 1. Hit OK. Now we're here. Something's not right. There's something fishy going on with this. Let me just double check real quick. Yeah, it's not happy about something. I wonder what's that. One text, two curves. Oh, it's my text right here. My section text. That's messing up. Let's go back. Sorry. So now this layout is created. It's gonna look like a mess to you as well, probably. Let's go back and let's check one thing that I probably missed to explain. The text, right? Everything that we had so far has had this, how do you call it? Scaling. Has had the scaling associated with it, except these letters here, A, B, you know, for the sections. So let's investigate these letters and just see what's going on there. I'll just type in options. No, I won't. I'll type in ungroup and select the text thingy, double click it and just see what does it say. It says height is set to be 653 millimeters, but the model space scale is set to be 1. That is not good. We want the model space scale, don't forget, to be 100, but then the problem becomes that our text is this big, right? Because it takes 638 and, you know, makes it 100. So instead here, I'm going to say the text is 6 millimeters big, like that. And now it's fine. So actually this is a little bit annoying, but I do need to ungroup all of these markups and select all of the text here and change it to the new style. This is what happens when you don't use a specific style, but you mess around with it, a very customized font for the text. So it's much better to actually first produce the style and then apply a certain style to all of your texts. Let me check one thing, if I can do this all at once. So I'm just holding down the shift key. I'm selecting all of the text. Then I'm gonna go to Properties tab. Perfect. Under Properties here, there are the settings that I can change. So I can change the height to 6 millimeters here. And the model space scale, I can change that to 100 millimeters. Oh, sorry, 1 to 100, like that. And now it all kind of matches up. And now I can go back to page 1 for some reason. It's still, my layout still doesn't change its name. Let's rename it one last time. If it keeps wanting it to be called page 1, we will let it. So you can change the layout either here or by right clicking and choosing to rename the layout right here, call it plan 1. Let's just do it this way. Plan 1. I think now it's happy. Okay, so our markups are fine. They're a little bit bloated, and you'll notice that if I zoom out, they get even bigger. The more I zoom in, the smaller they get. And this is because of the adaptive scaling, right? As I'm zooming in, the scale of the drawing becomes bigger, while the text tries to... It still retains the 1 to 100 scale that it's originally has been set. So it will always try to retain the 6mm size on the page. How do we make this drawing right here, first of all, centered? Well, first of all, how do you even zoom in? You double click. You double click inside of the sheet, inside of the detail. When you double click, you can position the detail as you want. And how do you center it? Well, you select the geometry that you want to center, in this case the whole drawing here, and you type in ZS. Hit enter, so it zooms and it locks the camera onto the geometry that you want to center here. Click outside, or sorry, double click outside of your detail view, or of your window frame, so that it becomes this kind of light gray color. Select this border right here and choose, once you select this border and you're in the properties tab, it's going to ask you what's the scale. So here, this is where you type in 1 to 100. And voila, now your drawing is at 1 to 100 scale in this view. Then we do this for every other drawing, right? So I'm just going to create a new layout. I'll just call this plan 2. I'll do this quickly. Plan 2, new layout, section AA. And actually section AA is going to be a landscape mode, not portrait mode, right? That's important. New layout, section BB. Also landscape mode. Then for plan 2, double click, select my drawing, ZS, zoom selected, double click out, select the border, 1 to 100. That's done. Section AA, double click, find my section AA. That is not it, this is it. Select my section. Yeah, most likely something like this. Zoom selected, zoom into it, click out, double click out rather, and 1 to 100. Something like that. Then we have section BB. Oh, right. Right here. Zoom selected, double click, 1 to 100. That's as easy as that. We have four layouts that all are 1 to 100 scale. Now it's time to make them print nice. Back in perspective view, or it doesn't really matter, you can be in any one of the views because we're going to be dealing with the layers. In these views, you can see that we have either layout print layout print settings, or we have print settings. So if you're only in perspective layer, you can only change the print settings. When you're in the layout layer, you can change the settings per layout. So I would strongly suggest that you first jump to either perspective, top view, front view, doesn't matter, non-layout view, and change the print settings right here before you jump into layouts and make kind of precise adjustments just for those particular layouts. One thing that I want to test out is, no, this is fine, never mind, it's all good. So under print, or rather, first of all, print color. So here in the model coloring, we have like blue hatch, red lines, and so on. The layout needs to be much nicer, right? So actually the model color is here, while the print color is actually here, these rhombus shapes. So we can change those. Let's click on every single one that is red, because that's our clipping plane intersections, and let's make them black. That's the first thing. Black, 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 black. For a hatch, I'm going to actually say, oh, actually no, hatch black. Landscape isocurves though, I will make them dark gray rather than black, just so that they are less present in the drawing. Text, I always like to make my text lavender or dark gray, depending if I'm printing in color or not. Dashed lines, definitely dark gray. Dimensions, red. Why not? Let's look at how they look like in the plan, and that's weird. Usually layout settings inherit. 1 second. Usually layout settings inherit the options here from the print. This is not the case right now. I have no idea why. That's not a problem. All you need to do is just change the... Oh no, never mind. It actually does. It actually does. It just shows you... you can see that in the layout, it shows you that I am currently showing you the lines and so on in this color, but I will be printing them in the rhombus color, right? So it's going to be printing them out in the correct color. If you want to see it in color that it's going to be printed in, the command for that is print display state on. And now it shows you how it's going to look like when it's being printed, right? That's pretty nice. Then in terms of thickness, it should also kind of show you the thickness. Right now we don't have that much going on here. Well, this is a thick line for the section through the staircase, but everything else is kind of the same. But if you want to change the thickness, it's right here, the layout print thickness, where you can change, you know, for instance, the landscape contour lines. You probably want those to be very thin, 0.13, the text very thin, 0.13, dashed line very thin, 0.13, dimensions, guess what? Yes, 0.13. Visible lines though, just visible curves, 0.25. Clipping plane sections for A3, 0.5 is fine, so we keep those. 0.25. So you just kind of specify for every layer what is the line thickness that you want. Just like that. Perfect. Also in the layout, you can, of course, you can create text and whatnot. Oh, oops. Create text, but this time around it needs to be with model space set to 1. And here you can create a name, plan at plus 0.800. That is very small. Let's make it bigger. Height, currently it's 1 millimeter. Let's make it 1 centimeter. That is too much. Let's make it 6 millimeters. Yeah, that seems fine. Of course, you would have like stamps and so on, like a proper architectural stamp here. I'm not going to teach you how to do that. That is not the part of the course. This changes to text as per usual, and if you want to copy it, you can just do Ctrl C, and then in plan 2, Ctrl V, and then change here plan at plus 4.8, and then section AA, AA 1 to 100. You know, very simplistic. Copy this, Ctrl V here, section BB, B 1 to 100. I should give the sections, the plans also the scale, but I'm not gonna be doing that. Okay, we have all of this set up. Now, how do you get a drawing, like a PDF drawing out of here? Well, all you need to do is just Ctrl P. It doesn't matter in which view you're at. Ctrl P or type in print. By the way, to get rid of the print display, you type in print display again and choose state off. And it's going to show you the original colors, or, you know, the working colors. It doesn't matter if you're in print display or not. Print, you just type in print in general, print, enter. It shows you what is gonna print. So we're at Rhino PDF, size A3, portrait, that's everything that we need. Vector, view and output scale. And here, this is where we actually need to specify which layout we're printing. I want to print all layouts, so I'm just gonna do that. Easy as that. Print all layouts. Let's go through them. You can see that it messes up here because I specifically made it so that the plan layouts are vertical and the section layouts are horizontal. You can't do that. It can only either print out the vertical layouts or horizontal, at least to my knowledge, right? So instead, what we'll do is we'll choose multiple layouts and we will just say layout number 1 and layout number 2. If you're not sure which ones are those, you can always check the numbering here. Plan 1, plan 2. 1, 2. Right? That's first, that's second. These two bad boys here. Okay. The scale is also always 1 to 1 because the scale is already controlled within the layout, so it's 1 to 1. Nothing else really needs to be changed. We print, we specify stage 4 plans available to download as well. We wait for it to freak out, or actually we don't. It's actually very fast. Well, yeah, we don't have that much going on. So give me a second, I'll fish it out for you to see. There we go. Perfect. Our measurements in millimeters, our staircase with the dashed lines, everything is in order, thick lines, the text, 2 pages, everything just simply works. Okay, now for the sections, again, this time I'll do Ctrl P. I'm more used to using Ctrl P. We choose multiple layouts. We choose the landscape. It's not going to be portrait, it's going to be landscape. Multiple layouts, 3 and 4. Let's just look at them. Yeah, that seems fine. Print. Stage 4. Sections. There we go. For some reason it doesn't open up. Okay, there we go. Not the prettiest, you know, but it does the trick. Also, the line thickness is a little bit on the thick side, so it eats up my frames. For A3, that is fine. So we have our little building here. Okay, that is about it in terms of creating drawings in Rhino. I don't think that there are any more additional things that I would like to cover for this particular portion. In terms of one last thing that I will mention is that it's very easy for this landscape to become NURBS polysurface. This is going to be the closing remark, awkward one at that. It's very easy to convert this into a polysurface, a closed one, like a box, and then Boolean difference out. I feel like this might be useful for those of you who are interested in creating 3D prints of your models, because this is still a single surface. So let me hide the landscape ISO curves layer. And this one, the sub-D, to convert it into NURBS, you just type in 2 NURBS. Hit enter, delete input objects. Well, in this case, I'll choose no, just so that we have both of them in the same place. When I try to select them, I always need to check here what I'm selecting. So let me just create a new layer real quick in the 3D rollout and call it landscape solid. Landscape solid, there we go. This one, I'll hide the sub-D. Okay, I can't hide the sub-D, I need to fish out the surface and add it to landscape solid, and now I hide the sub-D. And this is now not a poly surface, but rather, sorry, it's not sub-D geometry, it's a surface. And to make it enclosed, I could just extrude it this way, but that makes it a little bit ugly in the bottom. So instead I will do a little bit more of an elegant approach, where I'll duplicate border to get the perimeter here. Holding the Alt key, I'll copy the border down. Actually, by how much it doesn't really matter, but you know, a good fair amount. I'll scale it along the Z-axis down to 0 so that it's flat, super flat. Right? So we have a border here and a top border here. We have 2 curves. I will take the 2 curves, holding the Shift key, select both of them, and type in loft. Loft will ask me where the seam is. This seems like okay. Hit enter again, and this will create a border for me, right? So now I have 2 surfaces. I will select both of them, type in join. So now these are joined up. And then to fill in the bottom, which is flat, I will type in cap. So now this is a capped poly surface. Now I can take Ctrl Shift, select the bottom surface, and I can move it up so that it's not so intense to something like this. And to kind of get a negative, how do I call this? A hole. To get a hole in the landscape with the floor slabs, I will just use Boolean difference. Boolean difference, I'll subtract from this bad boy, enter. Subtract with, delete input no, but I will be subtracting with this floor slab, this beam or wall separator thing. And that's honestly about it, only these guys. Enter. And now if I were to hide all of this, I'm left with a hole in which the building could fit. And this hole, by the way, usually what we do is we CNC mill So we mill out the landscape and we 3D print the building itself, and we just kind of plop it in place in the hole, and it looks nice. Just so you know. But that is about it. That is all I wanted to kind of showcase with this course. It's, you know, heavily a beginner course in Rhino. I wish to do more of these, but this should get you started with using Rhino. And that's it. I don't want to make this awkward, so I'll see ya. Bye.